this on. Now, what the setting is, go ahead and show it to you here. Now, it's interesting because, and Sally, I checked a little further on this. I didn't, I still never encountered it on mine. So on either IntelliCAD or AutoCAD version with that set or unset. So it must be something that Carlson had been made aware of, and they have fixed the viewer, at least its sensitivity to it, in the newer versions. But here is what is going on. When you, if everybody has your stuff, who all had that problem with the viewer yesterday? Anybody that had it turn red in the 3D viewer? I know Sally had it.
Yeah, I had that.
Okay.
Yeah, me too.
I did too.
Okay. Go ahead and load up your software and take a look at, go ahead and do your view again. And let me know, it doesn't matter which drawing you use. It will happen in any drawing if this setting is set on your version. Okay, but go ahead and load up the viewer and look at it with the bounding box or color by elevation. Just let me know if anybody sees it again, because it tells me something about what's going on.
Do you
I see it
have
again on
anything up
mine.
on your screen?
Okay, I'm sorry.
What do you have up on your screen for us to see? I'm just seeing the Zoom thing, video.
Oh, really? No, you should be seeing, you know what's going on. Did my screen share not work? Looked like it shared the wrong screen. Let's get this one. Okay, is that better?
Yes.
Okay, good. Thanks. Yeah, I can't see what you are seeing when it shows that. It just apparently it picked the wrong screen. All right, so when you go to your 3D viewer window, and if you view by color, if it's all red, or if you have your bounding box turned on, it should be a good distribution of colors, and the bounding box should be all just grouped around the data. So somebody who had the problem yesterday, go ahead and load it up again now today and let me know what you see. Is it still that problem?
Yeah, mine's all red.
Okay.
Yeah, me too.
All right.
Mine is too.
All right. So go ahead and exit. And this tells me something. Tom, are you on right now still? This is probably something that Tom will need to fix. All right, so go ahead and exit the viewer and come back to the command line and type this command. OSNPZ, OSNAP-Z. And hit enter. Tell me what your value is.
Mine's set to 1.
Yeah, it should be set to 0. And that's why I need to talk with Tom. Tom, are you there now?
Yes, I am.
Okay, so OSNAP-Z being set on is what messes up that 3D viewer window for them. And,
Okay.
and that's not a system variable that stores anywhere. It's not saved with the drawing or with the session. So apparently it's in the either the startup Lisp routine. And it's not something that can even be saved with the drawing template. So it's probably in your startup Lisp file. Are you aware of that being set in any of your startup stuff?
Yes, I believe it is.
All right. So, and also here's another problem with that. Now it's not a bad system variable, and it is of some use. What that does is when you snap to certain geometry, it will prevent the snapping from reading that elevation and using it. So if I'm going to draw a 2D polyline, if I snap to something that has some elevation, that keeps that down at 0 when that variable is set on. So that's the intent, and it's to turn on and off, but you have to turn it on specifically for that drawing. So if it's on when they start things up, not only will it cause the problem with the 3D viewer, but it will also prevent them if they're trying to snap to certain 3D geometry, which is very common when we're setting our break lines and such like that, where we'll need the, if you're doing grip edits and things, if you try to grip edit a 3D polyline and have it snap to a location to something else for it to read that elevation, it won't do it. It only takes the XY. So
Okay.
that will need to be taken out and set to 0.
All right. Yeah, I
Just-
can definitely get that set up so that we don't have that in our new deployment.
Yeah. So now if it is something though, however, that is useful in your normal workflows, because I don't know the way you do a lot of your work, then you're just going to have to educate folks how to turn that on and off. Maybe if you're handy at writing, little utility routines, you could write something that puts it down on the status bar as one of the little clickable icons to toggle it on and off. That might be helpful. AutoCAD doesn't give that to you, at least not anymore. I think they may used to have years ago, but
Yeah, no, we got a few list routines. We can create one for that one as well.
okay. So you address that as you need, but just so that we're aware, and I apologize. We actually, tore that drawing apart yesterday, trying to figure out what was causing that to happen on some of their machines. And that's the cause of it. So if you, all of you, if you'll type that command on your command line again, if you haven't already, type osnap Z and then set it to 0. So you turn it off. And then you can double check your viewer. It should be working the way you'd expect it to work. And it will also snap your O snaps will read the Z coordinate of things you snap to. So just be aware of that. And there's another another reason to use, say, the Carlson tools, for instance, this draw 2D polyline, is that you can, in these options, even with your OSNAP Z set to 0, and where if you snap to the elevation of something, right up here at the top in these options, you can set the starting elevation. Or you could say, set the elevation by the first point that you pick. That's the way OSNAP Z equals 1. That's the way it works. I mean, equals 0. That's the way it works. If it's 1, it turns it off. But so if you don't have that checked though, and you're doing a 2D polyline, it will always force it to whatever elevation is in this box. And you typically would have that at 0, but you could put it, wherever it needs to be. So the Carlson draw polyline has that capability. The AutoCAD, polyline does not. It behaves at whatever setting that OSNAP Z is. If you snap to something with OSNAP Z set to 0, it will set that it'll set the 2D polyline to the first thing you snap to if you snap as a starting elevation. So just be aware of how that works and the fact you'll need it off to do most of the typical 3D editing that we do with this routine. Okay. And did everybody turns it off and then somebody go back in and check your viewer that should be working correctly now? Is that the case for you?
Yeah, so it works with the example 1 data,
Uh-huh.
but when I went back to the data we had yesterday, that T3 global, whatever it was,
Yeah, sample from T3 Global.
it had still red.
All right, if you exit the viewer there,
Yep.
type O snap Z and tell me what it is.
0.
So it is 0. All right, so if you are let me see, this is I'm gonna stop my screen share. Go ahead and share yours. Let me take a look at something real quick.
Shortly, but I'll be in this afternoon.
Okay, all right, so you still got that issue. Now let me request remote control here. And so you still got that. Now, it could be possible that there is some kind of data out there. So let's take a look at that first.
Ken, this morning, we saved it yesterday, you and I, but this morning I checked the OSNAP Z and it was set to 1.
Yeah,
But the viewer,
because it's in,
the viewer was correct.
Okay, there. You called.
The viewer worked correctly like we left it last night. I don't know if that makes a difference.
Yeah, that was sent to you. I thought.
it should, but it can still cause a I'm not sure if it's sensitive to any particular machinations of the data. This is all. Let me see here. If I erase this, but it will turn back on though, Sally, when you first start up AutoCAD. So that may be what
Oh,
you
you know, we're
check
just
and
sitting
make
here in our new office.
that it's off now, because it doesn't save. All right, so now everything here should be erased and cleared. If we go back and view that. Yeah, it's still showing that. Let me see. Sterling cleanup here a minute. 20,000. Yeah, give me anything set 0. Okay. Oops. It is 0. Okay, well. This is interesting. If it's not. Huh.
Gremlins.
Yeah, well. We can't deal with gremlins much. Let me see. All right, check it on other things when you, as we go along.
Yeah, the other stuff was fine. The other one that I tried this morning was fine.
It sits back and works correctly now.
Yep, the example one.
Yeah. So this is now I've erased every stray element that I can. Let's see if I find, oh, there's 2,910 elements. And if I remove, yeah, see, it leaves a total of 0. There's nothing outside. And then same thing on the, if I view it up like this. Let's see, if I do that. Yeah, all right, see, everything here is fine. But if I do this, there's something in this data down here that triggers that, I think. Nope. Okay, well, that's interesting. So if I view it all together, that's what happens. That's what causes it to happen. If I view it only selecting this stuff, or let me select it separately. No, that's still that. But if I do it independently, there's all the contours and such. They're all okay. And then if I do just selecting that stuff, and you see there's nothing that it's selected, of course. If I turn my ignore 0 switch off, it does pick up the non-elevated items. But if I look at those two things together, even if I select them separately, for some reason it kicks it up like this. Let me turn that off. Huh, well. All right, well, let's not dwell too much on this. We'll have to take this up with Carlson. It's not something that I've ever seen before. But let me know on any of the new stuff that we go over. Maybe there's something too that some manipulation we did. Snap Z is.
I just opened up the same drawing, did just what you did, and I still had the same results. And it was, oh, snap Z was 1, not 0.
Yeah, you need to
So-
make it 0.
Yeah, it still does the same view though.
And you still get that problem.
Same as you. Yep.
All right. Well, this is actually not me. This is, who's this? Oscars, I think.
Chris,
or yeah, Chris. All right. Sorry. So, well, we may have celebrated a little bit prematurely on that one, but I think that will fix it going forward. I don't know what's going on with that particular set of data. But don't worry too much about that. If you open, let's see, Chris, I'll let you go ahead and open one of your files somewhere else, or one of these other data files in the sample set. I don't care which, but yeah, that one's fine. And now go ahead and look at that. All right, it's even on opening the file, it sets to 1. All right, so Tom, if you're still there listening, that may be something that's set on the every time a file opens instead of when the session starts. Wow, that's got it there too. Well, it's very interesting. Again, turn it here. Look at it, it's fine. If I select and look at it, it's fine. Yeah, see that? There's nothing else in the data. Okay, well, apparently that's not fixing that. You still need your OSNAP Z set to 0 so that you can snap things to elevation, if that's your intent. So, all right, so Sally, we got, now let me see about something here. If you look at this one. Yeah, see, that one works. And if we turn it off, close it rather. And look at, all right, so now I'm opening that file. It says internal error, unrecognized SCAD version. So I'm not sure. OSNAP Z. Yeah, see, it comes up every time you open a file, it resets it to 1. Says if that's the default condition. So now if that is set to 1, I turn it back to 0. Now what happens if I insert yeah, Chris, navigate me to, oh, there's your Carlson class. That's what I was looking for. Materials, data sets, and that civil demo. I'll explode it so that it's not a block. Say okay. Double click it, there it is. My OSNAP Z is still 0. Yeah, it's still. Still an issue. Well,
What makes the difference is if you look at that front and only pick the top, not the 0 elevation,
sure.
it
Yeah.
will just show it the way you're
Yeah.
you're
Yeah, that's what I
wanting to
was
see
saying.
it.
I can do it that
Yeah.
way. You can adjust the top. And that looks like that's the way I want to see it. And I can also do this and select just the bottom. And even if that's, you know, turned on to not ignore zeros. So that still works exactly like it should work. But if I try that same process, if I select the top by itself, and as long as they're selected together, I get that.
Yeah, same here.
It's the act of selecting the data together
I'm
that
even
causes the
wondering,
problem.
yeah, we had that issue when we created the surface because of intersecting lines. And I'm wondering if it's like taking an average or somehow tying together two lines in the wrong way.
Yeah, well, I mean, we didn't do any surface work on this file. So that part's not there, but where we found it was working with Sally's stuff, where we found that variable being set to 1 was we were trying to do this. When you draw a 3D polyline, and if you uncheck this prompt for elevation, then if you snap to something that has an elevation, you see it's right now when I'm snapping to these corners, you see right in here on the status line, it's telling you what that elevation is, and it's setting that vertex to that elevation. When OSNAP Z is set to 1, and you draw a 3D poly, and you go to do this, even though that has an elevation, you see what it reports right here? That's what OSNAP Z does. So we were not ever getting, we're trying to set a break line by snapping to those 17 and 18 points, and it wouldn't read the elevations on it. So that does need to be 0, but that's still not fixing your view function. So there's something else going on with that. And again, I don't want to spend all our class time trying to find it. So I will check on that with Carlson. But if there's anything else going on, if Tom or anybody there knows a little bit more about what's going on under the hood with these setups, then let me know, or let somebody figure that out. So, all right, anyway, let's press ahead. And thanks, Chris, for sharing that up. So all righty, let's see. All right, so let's take a peek at where we were with the evaluations. Okay, so let's start looking for now at some of, So we talked a little bit about their field to finish on the fly yesterday about allowing those codes to set those edges for us. You saw they cleaned that up, but that's really about all that was demonstrating. Let me take a real quick pass through a couple of things here. Oh, Chris, any of you folks that are still getting that view, pull down the file menu and choose utilities and choose audit, or just type audit and tell it yes to fix any errors. And let me know if you got any errors.
Mine said 0 errors.
Yeah, okay, so that's, it was just an off chance to see if maybe something happened with those, but that's not the case. So, all right, I'll try to find that out from Carlson. Oh, if I can speak to somebody over lunch, I will. I'll try to get you an answer on that. They may not get back to me till later. So, all right. All right, so let's jump into some of the survey specific tools. And let's talk a little bit about some adjustments and what happens with those. We've got basically, if you're in the manual, in this the training guide, we've got two different types. Well, not really two different types. Well, yeah, I mean, there's multiple types of adjustments, but there are two different main approaches here. We have this raw file editing and processing, which includes your traditional survey measurement adjustments, things like the compass rule and Crandall rule and transit rule. And then you have SurvNet processing, which is your least squares adjustments. Which will take a set of observations and tweak them such that the systematic errors, at least, are minimized. It does some processing mathematically such that the errors that result from cross-checking, if you will, when things tie into it and it's measured from two different directions. And when they differ, that produces what's called a residual. And the term least squares means it's going to do the adjustment of that data such that the square of the residual distances is minimized, or it's made least. So it's a least squares adjustment. And it's fairly common and straightforward adjustment types. And the computer makes it possible for us to do it just as as we go along. This is also what is being done behind the scenes when you do a best fit for circles and lines and things like that through a bunch of points. And in fact, maybe that would be our that might actually illustrate, might be a good little illustration. So to introduce the concept, but let's go to Carlson. Let's just make a new file. And let's see, let's call this, we'll call it best fit. I'm going to make sure I'm sitting in my folder of my data sets. I'm going to call that best fit. And I'm going to make that it's regular. Oh, I also found out too something else. Do you remember yesterday when we looked at that field drawing? And you don't have to do this part of it. I'll show you this part as to how you discovered yesterday as well. If I set my coordinate file, and I'm going to go back to that man topo. And you remember when we see, yeah, you'll see that. All right, so if I draw all these points, I'll locate these points. We'll set that, elevations on the real Z, point numbers, descriptions, and draw. Okay, now watch what happens. And if you look down here in the right-hand part of my screen at the bottom, it says drawing points, and it's got this progress bar that's taking a long time. Okay, remember when that happened yesterday? It will eventually get there. All right, so there it is. And then when I did the least squares and I set up those routines to read the boundaries, and it still drew them in slow. And then I look around here and I had yesterday, it looks like that block placement issue is not happening, but you saw how slow it took. Well, that comes about, and again, if Tom, if you're on, this would be applicable. It depends on how you use points. I personally, when I use these points, I like to use the symbols, use the labels as part of my finished work. And I also use annotative scaling quite heavily. But what happens is under my point defaults, and I have my default set to right here, use annotative points down here at the bottom. And so what it's doing there is that it makes these blocks annotative, the symbols and the attributes. It makes those annotative blocks so that they will react to a change of scale. So there it is at 30 scale. If I look at it at 10 scale, you see the size of the points. And then if I look at it, say, at 100 scale, it places them so that the printed height of those is always going to be that 1/10 of an inch or 800ths or whatever it has to set to. So I like that behavior. However, that's what's causing it, and you need to turn it off in two places. I'm going to not use annotative points. You have to make sure also that your that this text style that defines those points, which is this PTXT, make sure it does not set to be annotative right here. And then you need to go to your settings, Carlson configure, general settings, and uncheck this right here to use annotated scale. Now that's also what causes your auto annotation and all those kind of things to take a little bit of time, because it's building those out of annotation scaling. So apparently that slows it down. So now if you look at the difference, I'm just going to go ahead and get rid of all of those. And I'm going to draw locate points and do a draw all. Now you saw the progress bar and how long that took a minute ago. If I do it now, boom, there it is. It's done. That's how fast. I'm betting those of you yesterday that didn't have the delay, that's probably how fast it worked. If you have those annotation settings, both here in Carlson Configure General, use annotation scale, or in your points defaults to use annotative points, or in any of the stuff that you're doing, if your font or your style, your text style is defined as being annotated, a lot of the Carlson routines take extra time to generate that text. So if I've got something like this, and if I'm using, oops, on that survey, use annotation scale, and I'll change my standard to be annotated. All right. Now, if I look at my annotation defaults, make sure that I'm using my text style as standard. That's for my bearings, my distance, find it here. And it's set to 0.08 height. And I'll say okay for that. My details. Now watch this. If I go to auto annotate, see how long it's taking before that comes up. So that might be, as you know, it doesn't take too long to generate. And if I erase, just freeze all my points for now so you don't have to see them. All right, so now because of that annotation, if I see that at 100 scale versus say 50 scale, it always keeps that such that that text is going to be the right or the proper height. So now if I have that off, all right, so now if I am not using annotation, as allowing annotated scaling, and if my text style is not annotated, and now I go to auto annotator, it's still taking a little while to bring that up. So, all right, so it's not affecting that all that much. However, what happens here when I change my annotation scale, obviously that's not changing. So it's a bit of a trade-off. I think it's going to be effective, or it will affect things speed-wise, and field to finish wise with the speed of drawing if you are using annotative points. Okay. Again, the way I like to work, I like to use my annotative scaling. So to me, it's a trade-off worth having, but it might not necessarily be something that you want to have to deal with. So if and a lot of folks, like again, like I said, a lot of survey companies, they won't give out any point data. If it's in the drawing and if it's a point, get rid of it. If you need to put, a circle for a property corner or a fire hydrant symbol or a telephone pole or a plus mark for a bench, any of those things, a lot of companies, they'll use the points to do the computations, and then they'll just put symbols at those locations, and then they'll erase those point blocks out of the drawing. And that's fine if that's your policy. I don't happen to work that way myself, but and I'm not making an endorsement of one way or the other. But if you do use that, and if you do like to use your annotation scaling to help you take care of those labels and such and symbol sizes, then you would want to turn your point defaults back to using annotative points and your Carlson configure general settings to use annotated scale. And then it doesn't really matter whether your style is set to be annotative or not. It will make that particular piece of text or attribute in the point blocks, it will make those annotative anytime it creates them. But if you just write text with those styles in play, those won't be annotative unless you go to their properties and change them specifically to be. So again, that might be a trade-off you're willing to deal with if you use your points a lot for your specific annotation. If you don't do much with your points other than show them in your drawing to help you do your drawing creation, then you get rid of them and you want the speed of the non-annotative text, then uncheck those items. Okay. All right, so now we wanted to talk a little bit about these best fit ideas and a little demonstration about as we start into our adjustments. So we've got, look, and it's all just import export. I want to find a good example. With these best fit curves, I can do it with that, but I also wanted to use we got best fit curve. Is that going to be our same? Yeah, that is. Okay. So this would be under our coordinate geometry. So if you look under your Kogo menu, and there is a little section down at the bottom, or a little pull right called best fit. And if you let's take a look at these items. So one of these items is best fit line by least squares. So what I want you to do is, let's do this. Let's do a ZC to zoom center. 5,000, 5,000. Then for the magnification height, let's type 500 and hit enter. Now, by the way, just so you know what that is asking you for, and that's just a CAD thing, it has nothing to do with Carlson. But if you do a ZC for zoom center and you tell it the center point, it's an XY location, 5,000, 5,000. So that puts that in the center of the screen, and then it asks for the magnification or the height. Well, the height is not putting you like 500 feet up in the air, which is what a lot of people might think it is. It's changing the magnification such that the height of the screen that you're looking at is 500 drawing units tall. So that's about 500 feet after you've done that command. It gives you a sense of scale. All right, so what I'd like to do next is we're going to drop a few points in here. I think the quickest way to do it, let's draw a 2D polyline. Doesn't matter the settings, but let's draw it with a couple of clicks and make it, you know, something that's a not, you know, something that's obviously not a straight line, but it is roughly in the form of a straight line so that you can see how this is going to work. Okay. And I'll select that and just make this so you can see it differentially once we're done. So there's our reference line that we just drew. And, you know, it looks like it's about, I don't know, about 700 or 800 feet long or so. All right, now go to Kogo and let's do create points from entities. And we'll just call this, doesn't matter the description, just so that we got them there. And I'll go ahead and bump my point numbers up. I guess I still got that man topo coordinate file open, and that doesn't matter either. If it prompts you for a coordinate file in this new file, if you haven't done it yet, go ahead and just go ahead and choose one of your choosing. We'll say, okay, make sure the polylines is turned on and make sure that you skip the midpoints. And then we'll say, okay, select the line we just drew, and it's going to prompt me now. All right. So it prompted me. I'm guessing for elevations when it did that. All right. So now I've got these points, and they are, let's imagine we surveyed the center of a country road somewhere, and we need to define that as a straight center line. So obviously, you know, the pavement might be a little bit wobbly, but we want to try to make that into a best fit. So if you go back to your Kogo menu, go to the best fit section. And if you come down to best fit line by least squares. And so it asks you now, all right, do you want to select the points from the screen or by point group, point number, whatever? We'll just say by screen. Selecting our objects, I'll just grab them all like that. Even though I've got the line, it doesn't matter. Now hit enter. All right, so the line I want to create, it'll be a 2D, it'll be fine. And it's going to go on whatever layer name. I'm going to draw the line. And now it will allow you to hold the bearing in which you type in a specific bearing, or you could hold a particular point. So if you hold say you're really comfortable with this point here, which would be 1001 to 1003. You could tell it, all right, hold 0.1003, and then you would give it a weight. This is a mathematical level of importance, if you will. By default, things are normally, or by definition, things have a unit weight of 1, but if you give it a higher weight, it's going to weight it further. Now you don't have to hold, you can look at the difference here. Let's go ahead and hold this point number 1003, point number with a weighting of 2. And let's draw the line. We'll say, okay. And now when this comes up, what it's going to show you are these points that it found, knows it's X and Y, or northing and easting, and it reads the residuals. And what that means is when it draws a line that goes through all of those points in a best fit condition, the residual is how far off that line each of those points is, okay? And you can see this one, point number 1004, which was 1001, 2, 3, 4. Well, that was the one that looks to be the most, has the greatest deviation. So, that's reporting that to us. And the next one you see is the one next to it. Looks like it's also the furthest out of the commonality if we're holding this particular point of 1003. Okay, so if we do that, go ahead and take these as they are, and we say, okay. Again, it will simply report that to you. Now I'll put this in the screen over here, so we can look at it. And here is that initial line. And if I'll make that one green because we'll do it a couple of times here. So there is the line, the best fit that goes through that point. That was the point we held. Looks like it's really, what was their residual of 1002 was pretty tight, 0.08. And then there's that 13. Distance away. If I measure that distance, so where did I put my, and where did I put my inquiry toolbar? Oh, there it is. And if I go from there perpendicularly to here, you see that distance, 130981, should be that right there that you see, that 130981. So that's what that is measuring, is that differential. Okay, so it doesn't go through 1001, doesn't go through 1002. Those are off by those little bits. It does go, well, doesn't go through it, but we held it. It's still 1.165 away. It should have held that point, but in any case, it adjusted this line to minimize the squares of those residuals. That's how it comes up with how, what angle to draw through those lines. Now, if we do that again, go to Kogo, best fit, line by these squares, again by screen. And we'll take our points here. Again, same points. And let's hold no points. And look at that one now. See, the residuals are slightly different because this allows you not to hold one particular points location. So we'll put this one over here. Slightly different. You can see, you know, it's roughly going to be parallel to that, but not exactly on it because our original minimized that 1003, which is where we said to hold that point. Okay. Now, the other thing about that and why we can use our use those differentials or residuals is I'm going to go ahead and look at that. We'll still let it go this same direction, everything we've just had, and we'll say, okay, but now you notice we may look at that data and decide that, well, you know, 12.75 feet outside of the best fit of this thing is not helpful. So I'm going to say that that point is probably a bad point, okay? And you can kind of get a sense of these. And if you decide you don't want to use it, well, you can select that, turn your processing off. So now over here in the process column, you see that's going to say no. And so now it recalculates a line and it's going to reposition that line. And this time it's going to be 15.5 feet away instead of 12 something away. But these items are going to be much tighter. And you notice I've also still got this one that's away. And if I decide that's a bad point, you can see how these things get even closer. And we say, okay. And we'll put that one down here. And so now this new one goes through 1, 2, 3, those 4 points the best, but it's in a slightly different position. It's such that this 1004 would be 14. So that got a little better than the time where when we took this one and this one out. See, when this one's pulled it back a little bit. But if we only took this one out, let's just do that 1001 through 1. Let's now just remove, sorry, not remove. So to not process it. So if I turn that processing off, shoot, I've got this, I had them out of order with one of them. So 1, 1, 2, 1, 6, there we go. All right, so if we, instead of getting 1.5 feet off like we have on that, where we considered everything, if I turn off just that one, it puts that at almost 16 feet away, but these are really close to it, except for the last two. It still has to miss those a bit. I'll say okay to that. I need to put that one in. Let's list the last. Okay, it's that bottom one. So this one is let's see that very well. There we go. So that yellow one now, you see it's a tighter fit even than the white line that was close when we took the others out. But this deviation that we told it not to process, but that took that out, you know, and has a greater what's called a residual, which is that distance away from this line. All right, so that's what we're doing when we talk about adjustments. And here again, you see how even this one has a residual, but it puts that through this set of points with the best fit through that least squares adjustment. So what we're doing in terms of a network adjustment, when we're talking about up here like ServNet and our least squares adjustments, that's essentially the same thing, but it works on combined networks of not just points, but the observations that put the points there, that calculated where the points are going to be. So it has not only a position, but it has a relative placement in terms of the distance between neighboring points, if those were observed, and the angles that were observed from other points to establish these positions. And it looks at all of that together and minimizes those residuals. And so it makes the squares of those residuals the least it can make them. So a least square adjustment. Okay, so that should give you a little bit of a sense of what's going on. You don't really need to know that. I mean, there's nearly entire college majors that govern numerical adjustment. There's certainly college courses, usually in the surveying curriculum, if you've studied that in school, you know, the Anderson, Davis, Foote, and McHale textbooks, all of those are going to, you know, really start to teach those concepts. And it's pretty heavy math. And we didn't do it in the old days because you can't do all that math by hand very fast. The computers now make that quite easy to do. So that's what we typically will do with when we do our adjustments. Now, here's a question for you folks, particularly those coming out of the field or maybe not coming out of the field, but those in the office doing the processing. When you process your data, when you bring in your data collector, I assume that a lot of your work is done using GPS observations, correct?
About 50-50.
Yeah, I'm sorry, Oscar, if you said you were muted when you.
I was saying we do about 50-50 GPS gun data collection.
Oh, there you go. I'm sorry. Whatever reason my speaker stuck. So say that one more time, Oscar. I'm sorry.
We do about 50-50 GPS versus gun for collecting data.
Okay. So do you ever, like when you're setting your control, are you still running some standard, you know, typical traverses to establish control?
We use GPS to get on grid, and then pretty much everything control-wise is set up with a standard traverse.
So you'll set a local
far GPS point, but
yeah. Okay. So you'll set a local traverse in for your control, and then of course you can you localize to that and get your rovers all set up to pick up your locations, your side shots and such, or go back and use the gun to grab it. Okay. So good. So that will be now. So a couple of things on what we're doing with these adjustments then. Do you all adjust your GPS observations, you know, through those least squares things, or do you use a correction service, a subscription service where you basically it dials in over the cell network?
We use both. We use network RTK and base rover.
Okay.
Sometimes we're holding the network GPS points to start the traverse to get us on grid, using it like that.
Okay, so you don't actually adjust your GPS observations. You're using that and relying on the network corrections that you you get to set those things up. It's the traversing that you are adjusting. Is that correct? Or do you, well,
Yeah,
the
that's
only, really, it's not all that terribly important. The only thing I'm telling you about is that when you can adjust your GPS observations. Okay, you can do that to where it will, try to minimize those error. But what you're adjusting is a signal from a satellite. You're not adjusting the distance on the ground, other than the way they tie in together relative to each other. So I guess it's possibly appropriate. So when you run adjustments in the office, you're probably, I'm guessing, just you're running those on your raw files that come out of your data collector. Would that be correct? And
Yes, that would be correct.
okay, and so what's in the raw file then are at least predominantly traverse observations, or distances and angles, as opposed to vectors from the satellites. Is that correct to assume?
Yeah, that is correct to assume. Certainly we use GPS points to control the hold the ends of our traverses.
Mhm.
Sometimes those get adjusted a little bit based on distances within the traverse, but we're typically holding the GPS points and adjusting in between them for open-ended traverses.
Okay,
And we're not adjusting topo GPS points. Just if we're doing any adjustment on GPS points, it's just going to be the control usually.
okay, all right, good. All right, so that's a little more, well, I'm gonna say it's not necessarily a little more typical, because oddly and sadly, there are those surveying companies nowadays that believe incorrectly that you don't need to do adjustments. They say, oh, our equipment's too good. We can't ever get any better. So we're just going to, take what it gives me. Well, I mean, that's fine, but you're putting every bit of the systematic error into your last observation. So, it's not necessarily a good approach. So let's see. Anyway, so here's another thing I want to talk about in terms of that as well. If you take, let's go to your points menu. Let's just draw locate points. And let's do a screen pick. And somewhere down below here, and it wants to know elevation, doesn't look. In fact, I'll just leave it at 0. And we'll call this one, I'll call it. There's my control A. That's fine. Take that there. I'm going to come over here and do another one here, and I'll call that one control B. And I'll come over here and call that one control C. And I'll finish that up. Let me see why I'm to automatic point number, so it doesn't prompt me for those anymore. Okay, now, so I've got essentially 2 control points out here that I would maybe sit on one, backside the other, and run my traverse to set my local control. Now, here's my question. When you do that, do you do something like this? If I'm, say, sitting on 1008, looking at 1007, Right, that is on. So two DP. And so 2007 to 2008. So 1007, not 2000. All right, one more time here. So 2 DP. So do you do something like this? All right, so there's my control. I would sit up here, backside 2007, and I would start traversing around, sitting there. I would sit here and maybe, go over here and set the control point, set a control point, set a control point, set a control point. And let's make that so you can see that. I forgot to, there we go. So do you do that, or do you do this, or actually maybe both? If you start here, now this is going to be a little odd to close back out quite this far, but I'm doing this to prove or to illustrate a point. Now, and some people call this yellow figure, they'll call that a closed traverse because it, quote, closes back on itself. Well, that's not really what the term closed traverse means, because even this is a closed traverse, meaning it starts on some known relationship and it closes on some known relationship. That's also closed. Open-ended traverses just are like fly lines. They just run out and leave something hanging in space. So when you're doing your work, how many of you do your traversing like this? Is that what you typically do? Or do you more typically always try to close into a couple of other known locations to close?
Yeah, we try and close in on 2.
Like you do close back on 2 different ones, right?
Yeah, if it's open.
Okay.
I guess you're calling it closed, but it's not a closed figure.
Correct. It is not a closed drawn figure. It's not a closed polyline, if you will. But that's still a closed traverse because it closes on known locations. But that's actually the better way to traverse than this. And the reason why a lot of people weren't necessarily aware of that. I'm just going to make an exact copy of that yellow one. And I'm going to scale it. So let's say and this is why it makes better sense to close to 2 different known control points than you started with, because if this is what you've done, you've measured those distances, assuming this one is, it's supposed to be 100 feet and 100 feet, 126 feet, whatever, and it closes back on itself, you're going to miss this with a little bit of misclosure, and it's going to be something you'll adjust out, and you'll feel good about that at the end of the day. However, all you're adjusting in that case is the angular error. Because if you have, well, the angular error and the random distance error, but your instruments also have instrument errors, or what are called systematic errors. So let's say your instrument has a scaling error and it reads your distances all 3/4 or 25% too short. It reads them back. The scaling is not correct. So when it will tell you that it's 100 feet, but in reality, it's only 75 feet. So that would be a condition that, whereas this is what you're expecting, that's what you're actually getting. Okay. So the thing is, the angles all read exactly the same as these angles, and the distances are whatever it's telling you that they are. But when I read those exact same angles, I sit here, I turn this angle, and I turn this angle, turn this angle, turn this angle. If I close back to where I start, then I have no way to adjust for that distance differential. Whereas if I think I did close the figure. Let's try that one more time. Okay, so maybe we'll get that done. Delete. And so if I do, like I said, there's my last observation. It's going to always bring me back where I started. But if I take that same distance and that, all right, so relative. So if I take that same distance, so I won't be changing the distance, but I close out to a different known control over here, I'm going to know by the fact that I miss, from this endpoint, my angles all match, but by the time I get up here, my distances are way off. Okay. Or actually this would be, 3/4 of what this distance is. So in that case, if you, well, anyway, you get the idea of what I'm trying to say. So even though we do this closed figure bit and it's convenient, and especially for smaller jobs, and it's reasonably good enough, but we don't ever have the capability of finding those scaling errors. Now, we had a situation back in the early 90s. I think I was working for a landfill design firm down in southern West Virginia. In fact, it's why I wound up in Pittsburgh. Was we had this company in Pittsburgh that was doing aerial mapping for us and giving us CAD files that we could do our design on top of, which was in the early days back then. And these were large sites, 5, 6, 8,000 acre sites at 2-foot contour interval and contour mapping. So it was pretty large and pretty intense. So we had this one particular job that from side to side, we had to build a lot of things around the entrances, some gates and access control points, things like that. by the time we got onto the other side of the property, the 6,000 acre property, you know, it's several, you know, maybe a mile or two across or something, or a half mile or some, whatever it was. By the time we get over there, we start missing things by 6 inches, 8 inches, something like that. And so I noticed, you know, everything was sort of off. So I got on the phone with these guys in the surveying department, the control group, and trying to figure out what's going on. I said, well, you know, send me your analytics setups, your control reports. Give me your camera calibrations. You know, we're trying to find out what was going on. Well, come find out, they hired a local surveyor down there to run the control that they use to set up their the photogrammetric control. And he did it like this. He brought his control in from way down the mountain and ran it up to where the landfill site was. And then he started around and he just closed back on himself. And he said, okay, see, there's my closure. Well, it turns out he actually did have a scaling error in his EDM. Wasn't much, but it was enough over the size of our site that we were missing things edge to edge by some fairly significant amount. And I mean, this almost went into lawsuits. We managed not to do so because we were able to go back and they could go back and retraverse that and tie it into a couple of other known points. And they recompiled the photogrammetry, sent it back, and you start doing those comparisons. That's where you started to notice those errors. So like I said, you're not going to notice it in something relative to itself until you try to translate that back out on the ground. You're not going to see it in something unless it's a large enough area that you would see it, or if the scaling factor is really an issue with your instruments. Okay. So all of that being said, what you can do a complete mind dump on now is just to give you a sense of what we what it is we're trying to do when we make these measurement adjustments. Because you're going to see, especially as our equipment gets better and better, there's not a whole lot of real fixing that goes on any given one particular measurement, but it's that accumulation throughout that whole file that fixes things and keeps things as true as they need to be based on the rules of the geometry that you're working on. Now, do you folks do anything? Do you do like grid factor and sea level factor reduction on any of your measurements? Are you doing any type of geodetic type of work, or is it pretty much standard survey stuff?
I mean, we certainly do on the large sites that, we deem warrant, but for the smaller stuff now, we're just going with what we got.
Okay. All right. Well, I mean, like I said, we can spend an entire college career trying to, delve into the science of adjustments. And I don't, I'm not trying to imply that I know all that stuff in depth either, because we don't use it every day. But so let's see where these tools are and how that goes about coming into play. Now it is, let's see, we're an hour and a half. Yeah, we are right at mid-morning. So we'll go ahead and we'll take a break. Sorry about that. Forgot to turn my phone off. So we'll come back at, quarter till, give you your full 15 minutes. So let's come back at 10 till, and then we'll go on. And now, do you guys want to, because we started a half hour later, do you want to keep your lunch at 11:30, even though we haven't really hit it that close to 11:30, or do you want to go to 12, or what's your thinking?
Well, it's fine.
If we do a half hour lunch, ooh.
Well, you really kind of need a full hour. I need a full hour myself
yeah.
to try to take care of things that have happened all morning that I'm that I'm trying to get rid of. But you do need to let your brain rest a little bit, although it's not all that taxing for what we've done for now. But all right, so let's come back at say 10 till, and so I'll give you your morning break, and then we'll go to. Well, let's compromise. We'll take our lunch at 11:45. We'll try to target that, but you'll still get your full hour. Okay. So,
Okay.
all righty, I will turn this off and so now I am, if you're following along, I'm on page 60 of the guide, which is page 66 if you're looking for page numbers in the sidebars of your PDF viewer, but it's numbered page 60 in the book. It's where we're going to talk about a couple of things. We typically, like it'll say up here at the top, we're typically in doing things like simple total station adjustment or traversing adjustments where we adjust our angles and distances to bring those back into compliance, and that's out of our raw file data. And so we typically will, apply an angular adjustment to take that out of our observations, and then after that's been made, we'll adjust the coordinate positions by one of three typical rules: the compass rule, transit rule, or Crandall rule. And compass rule adjustments now are the preferred methodology because of the instruments that we're using. Total stations, and you can see there, it talks about it assumes the angular measurements are as precise as the distance measurements, whereas transit rule adjustments assume angles are more precise. So like back in the old days when we used transits to measure the angles but tapes to measure the distance, then that was why we use that transit rule. And Crandall rule makes the same assumption but provides a limited least squares adjustment, a bit easier to compute. And when I say a limited least squares type adjustment, it was basically the same math that a least squares adjustment uses, but everything is set to a unit weight of 1. So therefore it assumes the equal precision on those measurements. And when all of those weightings are set to 1, a lot of those terms in the least squares equations will cancel each other out. So you're left with what that will come up with. But again, compass rule is a good overall general approach on that. And so I said, assuming our instruments are in good adjustment, that would be what we would do in those three more traditional type adjustment processes. These squares adjustments, however, does this best fit solution where there have to be redundant measurements to really take advantage of that because it resolves those. So this excess measurements of certain variables that makes up that model, and it's a system of equations, different knowns and unknowns. And then the criteria, the least squares criteria is reached when the sum of the squares of the residuals or the individual spreads of each measurement from that predicted model are minimized or made least. Okay. So the first one let's look at, just to get their feet wet on this, is some typical raw file processing. Now, raw files are what we collect on our data collector. And since you're using Serve CE on your data collectors, you won't have to worry about any conversions. You're going to have an RW5 file. And the RW5 format is one that was actually started years ago, I think, by TDS. I think that was the company that first used that, and Carlson has kept that same format. And it's just an arrangement of how the data is stored internally. And you can see when we get into that processing part that, you know, you can convert from many other data collector types. It will convert those for you. Okay, now this is also, you know, we have two sort of traditional raw files. One that you could just type data in by hand, and that's what you would have done back in the days of reducing field notes. But it can also be created, if you remember in our setup under settings, Carlson figure survey, we had this bit when we're doing coordinate geometry. When we're doing coordinate geometry calculations, we can turn on, either automatically turn on the raw file to collect those computations, or you can manually do it as you're doing it on the fly. So what that does is it records those computations as a series of either traverse options where you're sitting on a point, backsliding a point, you're turning an angle and measuring the distance to compute the point ahead. And if you're traversing, it repositions your occupied point to the move up point number. If you're doing side shots, it keeps you there and lets you keep doing side shots. And it just records those in a raw file as if you were out in the field doing it. Now, the other method is if you use your total station to go out into the field and do your data collection, it records those, and you'll see the differences in the two when we look at that data. Now, another nice thing about the raw file when you're doing it out in the field with your instruments, do you guys typically turn sets of angles, or at least close the horizon on your on every setup?
Yeah, we always turn sets, and usually we close horizons on spurs that are like more than 3 stations, open spur.
Okay. All right. So the nice thing about this is that it records all of those, you know, whether you're looking at a foresight direct, foresight reverse, backsight direct and reverse, it will record all of those individual settings, and then it will reduce those. And this is, if any of you are old enough, and I really doubt that you really would be, but back in the days when we did everything with field notes, you know, we would turn multiple sets of angles and have to compute our averages, you know, right there in the field on our field book page before we went ahead. And you know, you tend to get pretty good and pretty fast at it if you do that every day, but that's not something we typically do anymore. We let the computer take care of that when we get back to the office and process the raw file. So plus the data collector will let you know if you're out of tolerance as well as you're going. So, but that's really what this has become, is simply a digital version of what we did with field notes before we, you know, we're into this modern era. Okay. So now we are going to let's look at, go ahead and open a new file, and let's open up raw file 1 as a new file. So go ahead and make a new file, or you could even go to a place. I'm going to set a new coordinate file here. I'm going to call this one raw file. Let me put these back in all caps so you can read it a little easier. So I now have an empty coordinate file, and I'm going to go to the survey menu, and I'm going to edit and process my raw data. And by the way, One thing I want to show you about some of these menus and the way they're structured. Just to put a little quick side trip here. Many of these, typically from the survey menu on over, not so much these fundamental commands, but things like this survey or even under centerline, you've got a bunch of things up here at the top that allow you to either create the file or edit the file. And then after you're done, you've got further commands that are either going to process the file or draw the file or generate reports about the file. So that's pretty typical. So under survey is edit. Now that combines the processing into the edit function as well. So just in general, that's how these are structured. So a lot of the edit, create commands are up at the top because that's typically the first things you would do. All right, so let's edit, process a raw file. And again, you could, once you were familiar with this, you could just enter these in here, you know, just like a little spreadsheet. You would pull down a type of observation, you would enter the data and proceed. But since we have a raw file, and you're typically going to always have one, let's go ahead and open. And you know what I need to do real quick? Bear with, go and leave yours where you are. I need to set my directory structure up better. I need to go into that location here. There we go. I'll just call this one raw file. Processing a new file. That's all good. Let's say next. And that'll be fine. I'll say next. Okay, so now you go to survey, edit, process raw data. Now when we open in your data structure, you're going to see one called raw file 1.rw5. Go ahead and open that. Notice on our file menu, you can also import all of these different types of raw files. And some of them are just exactly the same, like that TDS, I think is the exact same one, the same format, I believe. All right, so a couple of things you can, let's talk about in the editor here. You may see a blank area down here below, or it might be you know, it might be blank like this, or you might see the results of what that raw file generated. Okay, so that is right now looking at the graphics, and that is controlled by this display or under graphics, whether it is on or off. So if I turn it off, that goes away. Now that these buttons here are the typical commands from these menus that you would use. You just hover the mouse and it'll tell you what the command is. So that's graphics on or off. Okay. And the graphics are on, and then if there's any side shots, if you turn your side shot, that toggles them to show on or off. This is just strictly a traverse. So you can open the raw file, make a new raw file, save it, or save it as a different name. And you can also open or create new, save and save as your coordinate file as well. We already have one open, and you can see that up here at the top stripe in the editor. It tells me the name of the raw file, tells me the name of my coordinate file. And there's a third one here called control. Now what this does with a control file is I can choose a set of control coordinates out of a different coordinate file if I choose to do that. In our case here, we're just setting up, it's a very simple little square-sided traverse with one particular bed bust, and you'll see how it's applying those corrections. Okay, so that's a secondary control file that allows you to keep that separate. So you may have a set of control coordinates that you keep in a separate coordinate file, and you're not going to touch those, and it won't make any edits to those points. It's only going to work on the ones that you have. Or you could have already imported them into your current coordinate file. All right, so a couple of other things here. Let's look in the file menu and look at our open and save settings. If you want it to, it can prompt you for the raw file to use. As soon as you start the command, it will ask you for the raw file, or you can choose to open or create new. And these two descriptions, a closing shot or an angle balance, these are descriptions on the points from your data collector that if you see that naming that point, if that is in the description of that point, that signals that, hey, this is a closing shot and this is my angle balance shot. You have it automatically save your coordinate file if you want, or you can have it go through different adjustments. Don't automatically save it, because if you save it automatically as you go through, you make one adjustment, you change something and try a different adjustment. Then what it's adjusting at this point is the newly saved from the last step. So I'd recommend leaving that off until you're through with the processing, and then it will prompt you. It won't let you close without telling it whether you want to save the adjusted coordinates or not. Okay. All right, so that's some of those. You got your imports and exports again as well. Let's see here. There's nothing to worry about that. Reporting and printing. And again, it just reports what you're going to see here. Here's the settings on what you're going to, what happens when you run the report. Generator, you can, if you want latitude and longitude, you can change those to decimal degrees if you'd like, using decimal seconds for your direct reverse report, because those are averaged angle measurements and they could turn out to be, you know, a portion of seconds. Otherwise, it will just report it. It still uses the computed average, but it will report whether or not you're using those. So you can see those are pretty standard options. Are pretty self-explanatory there. Okay, so let's see, what did we see? Anything else? Raw data, sorry, that's, and then there's the settings. All right, so then our editor, your typical spreadsheet type editing functions: undo what you've just done, cut, copy, paste, find, replace, goes, delete a row, modify the different measurements. All right, so these are all, and this one, edit the coordinate file, it actually takes you straight to the same editor that you would use if you had double clicked, you know, and you can step through those different points. And you would see those values if you had values in them at this point. We don't yet. All right, and then our display is, again, you can see the different options here. I think we're using zenith angles in here. So 90 degrees is flat as opposed to 0. If you're using 0 as flat, you would set that to vertical angle. And what distances that you're going to record in our case, because this little example, these are all flat, so we could just make those horizontal distances, but it would do the reduction for you. Now, graphics on and off, that toggles the display down here below. Whether or not we see the side shots, again, if we have side shots, that will show those. And then zoom mode means I've got three modes here: zooming, panning, or pick, and a fixed text size, or you can resize the text as you zoom in closer. And that works down here. So the also that, and you can see these options here, zoom extents, there's your pan, your pick. So if you choose the pan cursor, it will show you like that. If you use the pick cursor, it turns into this, and you can pick a particular item. In this case, it's that observation. Notice it highlights. Now I can just, when I highlight that element, it also jumps to that record in the raw file. You can see as it's working its way through. Okay, so when you pick a point, when you pick on a point, if it's a multiple points because it's not looking at what's in there yet, then if I go back to my zoom cursor, I press and hold the mouse and either push it away or pull, up or down will change the relative zoom. I thought they had it to where the wheel on the mouse would work. It's not. Yeah, it's just going to be a cursor. The wheel still works for panning. You press and hold the wheel, that will pan. Yeah, we'll go back to zoom extent. So anyway, just a couple of little interface items here. And let's see, graphics zoom. And then the rest of these are your processing. So you're going to process the data with no adjustment, that just computes raw positions, then do an angle balance, and there's your compass rule. And this is if you're processing GPS observations, which again, you're typically going to use those from your, you're going to use your GPS to establish your control. So it's not going to adjust the actual recorded measurements from your GPS observations unless you choose to do that. And then this one is I'm not sure, that should be. It may, I'm not sure what this one actually does. I don't see it doing anything. Well, let's see. Yeah, they're not going to explain it here either, I don't think.
Yeah, it looks like it's a process ServNet.
Okay, does that kick it? It's into ServNet. That's what I was thinking. Does it use ServNet or does it use their built-in least squares? That's what I wondered. And the reason I asked that question is that this will actually do two different types of adjustments. If I'm in here, now when you click that, do you get something that pops up?
Yeah, it goes into ServNet.
Yeah, that's what I was thinking it was supposed to do. I don't know why mine's not. Everything's all contained on one screen. Oh, they've taken that, broken that part of the interface here in this version. So what that does is a way to kick you in and out of. Now notice under process, under least squares, this is the single network only least squares adjustment that Carlson wrote. under, let me close that back off real quick. Under our processing here, there's a separate system, the ServNet least squares, and that's where you would get, you know, data file. Okay, so this is actually probably quite a bit different from when you choose that as a command. You're going to get up this as a, instead of a docked control, you're going to get it as a separate little set of windows. Okay, so that's probably why it no longer works under this. That doesn't kick into that. This would normally bring up that other set of windows. So that brings up that, and ServNet is the multiple network adjustment that C&G actually wrote, the old Cowherd and Goodman system, which a lot of surveying companies back in the day would buy C&G software just to get that ServNet adjustment capability, because Carlson didn't have it yet. Some people used a program called StarNet where they did that separately as well. Now, Carlson just found it easier to buy C&G survey software company outright, and that's why you had those C&G survey menus are available as well, because a lot of customers used C&G software for their total system, but they bought that company just to get that multiple network least squares adjustment capability and bring it in. But that's not typically done from inside your raw file processing. That's more typically done on that separate pull down command. But regardless, that's what those do. So this one won't work in the 2022 version because it doesn't, you know, it's trying to kick up those old windows, and it's been now changed into a dockable control panel. So anyway, that's what those are going to do. But let's take a look at what we have here. We've got a couple of things you can see. I've got a blank, what looks like a blank record. If it's blank in this first column, this column here is the type of observation or data that's on that particular row. The next column is either a heading for the data that's underneath it. So it's point number 1. This is the northing and easting elevation and a description. Okay, so every time you change the type of record, and PT means to store a point, and you see these different options. There's TR for traverse, there's side shot. You can enter an HI, enter a backside, store a point. A DS is a description, I think, then a closing. And notice the heading now changed from point number in northing and easting. It changed to occupied, foresight point, code, horizontal angle. And it also changes these headings up here at the top as well. So this was actually a point record. All right, so you're going to see those. Now, you could notice as I switch in here, do you all see these headings reported up here at the top? I better check if the versions are still the same. Or do you only see headings in the screen or in the record?
I'm just seeing them in the record.
So if you click on one of these lines that has a type in this column, you don't see these headings up here.
Oh, okay. When I click them, they appear. Yep.
All right, so you see those. So that is something that you could so show descriptions, show record headers. And so if you, that that X, that checkbox wasn't showing up right. So if I say show record headers, you see they'll show up here as they'll take up a line in the spreadsheet to show you, when you're working down here. But if you see them up here and get used to looking for them up there, you can save a little screen real estate if you choose to hide the record headers. And so now when you sit on a point, you see that header is changing for each time you have a different type of record. Okay. And there's another way you can separate all of these things as well. If you look under the display menu and your spreadsheet colors, you can say, all right, I want traverse measurements to show up in a particular color. I want a side shot to show up. Maybe I want my side shots to be green. If I'm doing sets, they're going to be this sort of brown mustardy looking color. HIs and rod heights, flag them up as red colored so you can go to them quickly. Backslights are magenta. A point record is black. You can get the idea. So you can set all of these things up to display. It also just helps you keep track of what you're using. Let's see, did I have any other? Yep, that should be about it. Okay. And there's also, you can set the headers if you want to use large font. Now that doesn't change these, it changes in here. So it's not, spreadsheet settings. There we go. Let's put those back. All right. And then you can, basically hide and show rows. If you select a few rows, you say, I don't want to see all those records. You can hide them and turn them back on, much like a spreadsheet does. All right. So, and again, track your changes if you wish. There's all kinds of them. I'm going to show my side shots. I'm going to show my graphics back on. There it is. All right, so that's just basically some visual cues as to what these are going to look like. So there's my traverse points, there's my backside, there's my store point. From store point number 1, 5,000, 5,000. Yes, I know. So, but just as a real quick walkthrough example, that's what we've got. Now, we go to the processing tool, and when you're putting these in down here, now I haven't tested to see whether they've resolved this. You used to have to, like if I were to go into that and type in, or go into a new record and type in TR for traverse, it wouldn't recognize it. You have to pull this down and choose it from this list, even though in the data itself, out in the raw data file, it's just text. It's just those 2 letters, but you had to pick it from that list. So when it offers you that pull down, I would just say, get used to that pull down. I'm going to actually show those record headers here as well. Just so that we can see them as we get to them. All right, now. So what we have, if we look at our little figure down here, we have a very bad form of traversing. We've set on a point here, point number 1, and we backslided a direction, which we didn't actually compute. We didn't have a point back there, which maybe sighted on a, I don't know, church steeple or whatever, and we gave that as our 0 for our plates, and then we started turning angles. So we turned, this first angle of 180 degrees and went 100 feet at no vertical angle and set our next point. We go to point number 2, which is our occupied point, and it now backsides 1 up here. So it's backsiding that record that set our first backside. And then we're sitting at number 2 and we're looking head to number 3 and we turn an angle right of 270, go 100 feet. So again, as you would imagine, then it moves us up to that point 3. And because we're in traverse mode, it keeps upping the occupied point, and it's not showing you the backsite point here. This is just a backsite record for where we took the first backsite measurement. This up here is. But because we're traversing, it's going to always keep the previously occupied traverse point as our backsite as we move up. So now we're at 3, going to 4. We're going to turn an angle right. Notice you've got, angle right, angle left, deflection right, deflection left, azimuth, or a particular bearing. And then there you see I've got 2 seconds off from my 270. So there's my error, and I've got 200ths off from my expected distance. And so that's number 4. We go to number 5 and go to, or we're sitting on 4, we're going to set number 5. We turn that angle 270, 100. And notice this description. I've got trav 5 equals 1. And I'll show you what that means when we look at the processing section. That's just a flag that says that point, my new point number 5, should be the same as number 1. Okay. And that happens to be a closing record. That's why it's CL. And then an angle balance is where we turn back into our 0.99, which should have been a 90 degrees in whatever angle or whatever distance. And again, just a close angle. Now that could be, let's see, what did we had? We could say closure and angle balance. So if I said instead of close angle, if I had angle bow, and I could have done the same thing. We'll get this open so we're not scrolling all the time. And then the same thing, closure, I could have simply said closure up here and it would have done the same type of thing. It knows that I'm closing back. Right. But this equal is also a way when you're checking into, like maybe you're not going to check back into that number 1, you're going to go out here and do some work. You're going to check into another point that lets you tell it that that's supposed to be the same point, even though you compute a new position for it. Okay. So that's the basic form of what we're looking at. And let's go now to a couple of processing options. If we look at our process compute points menu and choose process settings, here's where some of that comes into play. All right, up in here, we've got a distance tolerance, and that's a little bit big. Let's call it 0.01. And the reason I'm going to put that as 0.01 because I've got a distance down here that's going to show up. It's 200ths out. So that's going to be, it's going to exceed that expected distance, and you'll see a warning message pop up. Verticals, this is the, so it's half a second in my vertical comparisons. Now this actually may not, this distance horizontal, that may be for, that's when we're doing multiple, when we're doing sets. So that's when you're going to see that pop up. So that won't show there. We'll do it when we get to our larger file, you'll see that value come into play. And we're going to tell it to report residuals. We're going to average our distance measurements as opposed to averaging our coordinates that are computed, which in this simple example, that's exactly the same. But if we have multiple sets, it's going to average these distance measurements and apply one distance to compute the new coordinate. If we say coordinates, computes each of those coordinates from those multiple measurements and then averages those coordinates. So it's a slightly different result for that. When your backlight orientations, now do you see any differences in your settings here? Like, do you have this override backside azimuth? And really,
Yeah, that,
you have that on. So what that means is if I'm using a separate control file, like you see up here, right now it says none. But if I have a control file and I could say, I could type in an azimuth or enter an azimuth on the data collector even as I'm doing it, but this says, all right, ignore that and go out and compute the azimuth from that coordinate file if you're having it on. And you can use multiple references, yes or no, and apply your collimation corrections from your pointing. Back off. Now, checkpoint settings. I'm going to report the checkpoints, and right here is the code equals. That's this trav5 equals 1. And so that means I want you to check in, and again, I'll set this down to instead of half a foot. These are all set with default values in this new version. I haven't run through that on this version, so that's why they're sort of, half a foot. That's a bit of a bit of a free tolerance. All right, and then if you want to store that point record to the coordinate file, you can always do it, or only when the coordinate file is empty. So if you've already got coordinates in there, it won't store them. Now it will adjust and compute, and then when you exit it offers to save, then it will still save. So that's, even if you say never, when it asks you if you want to save, it will ignore that setting and go ahead and save those storing the points. And or actually not the computed points, but the store point, right? Like this record number 2 up here where I'm just basically entering the coordinate for point number 1. And so that's a store point record. So you want the store point record to go to the coordinate file. But if I set that to when the coordinate file is empty, so if I already have a point number 1 with a coordinate value, even though I store it here and that's what's used when I compute things, it still won't override that value in my coordinate file if I have it to never or always or when it's empty. All right, so let's see, store point record to coordinate file. Yes, and now the convert occupied points to point records. If I enter that as an occupied points, that just converts the type up here to a PT instead of an OC. There's no real need to do that. All right, then for our angle only measurements, the elevation methods, we'll just set that to average. And here's our data checks. If you've got any blank descriptions, it will report those just as a reminder if you need to put a description in. And then instrument heights and rod heights, you could set this up to a value so that if you mistype it, it will flag it for you. So, set that to something that's you're always over 3.5 on your instrument, and you never. I had the tab out of that. There we go. All right. So if you're never over, 8 feet tall or something on an instrument, same thing with the rod. If you use a fixed height rod, you might set that to the same value, min and max. Let's just say 3.5, and I don't know, I had a 25-foot rod, and if I booted the rod, which I hope nobody's doing rod boots anymore, but let's just say 25. All right, so anything over that, if I put those values in, if it's not within that range, it's going to flag for you. Now, when you are taking direct and reverse readings, you want to balance those or just take the direct only. And what it does is it compares these when it computes it, reports it to you, but will only use the direct. And the reason that's there is because sometimes when you're, some people will operate in the field, they'll take a lot more care on their direct pointings, but their backs or their reverse readings, they're a little sloppier with it. Typically though, hopefully you're doing the same on each. So you want to balance those. And then your foresight, backsight measurements, again, same thing there. You might want to balance those. Now our horizontal angle tolerance, let's see, this up here is not this angle, this is a distance. Let's set that to 0.05. There we go. Same thing here. And again, I'm just setting values that it will report a warning if we need to. So depending on your instrument, if you've got a, if you've got a half second total station, you would put that in as, 0.5 seconds. This is a half minute gun. I don't know what you might be, maybe a 10-second gun. And then this will be your flipping. So when you flop the scope, how, what kind of tolerance do you want to report if you're out of measurements? Let's put that back to, let's make it maybe 5 seconds. And then a distance tolerance again for doubled distances. So another thing to notice on these dialogues, and this applies to any dialogue in the software, you get a bunch of stuff here, a bunch of stuff here, a bunch of stuff here, but it's all grouped together with this little outside frame you can see there, gray. And this has to do with your direct and reverse readings. Okay, and then any measurements you make into control points, you want to store that to the coordinate file. Yes or no, and then drawing points and line work. If you draw, it has the option here to draw by field to finish, which you could do. It would go ahead and start that field to finish process for you. I tend to not do that myself, just so that I can, I'll do that as a separate step when I draw field to finish with that command. It can automatically do it, or you can have it prompt you if you want it to use it. Okay, and if you do choose one of those other two, you have to set a table, tell it to use. All right, so those are our process settings. That controls what's going to happen when we do the work. So let's do a first pass through here with a no adjust. And we don't have any here, but if you have multiple measurements to the same point, you can read the choices there. I'll take the average, use backsight reciprocals. Let's average both elevation and distance, calculate the elevations. If you don't want to carry elevations on your traverse stations, you would set that for side shot only, but I'll go ahead and make it for everything. And then if you say point protect, if you've already got the point in there, it won't overwrite the point in the coordinate file when you're done. Scale factors, if you're using those based on your grid locations. And so we'll turn it off. We're in the 5,000 world. Earth curvature correction. So all of these things you can set up and process here. How you want it to report, just a standard report viewer. That's that one that you saw when we did the least squares line fit, or the custom report formatter. When the report pops up, you have to then build the report, and that may be what you want to use. Report the angles. you can, even if you're entering azimuths and bearings or whatever, you could output it as angle right or output them all as azimuths, or just take whatever's in the raw file. How many decimal places? 3 should do us. Report the closure, report the side shots. And then if you have a reference closing point at this point, and we'll put this back in later when we run the process. Let's see, we're processing around. We come here to point number 5, but the reference closing point would be point number 1, 5,005. So that's what it's trying to close back into. And we'll say, okay. All right, so now it wants to know the traverse points. Now it's pretty good at figuring out from the raw file what the intent was. So it goes from point 1 to point 5, and that's just automatic. If you say prompt, then when you run it, it will pop it up and ask you right here, 1 to 2 to 3 to 4 to 5. Okay, so let's go back to no adjust. Put this in. All right, so now if I say okay, and let's see, did I choose the automatic? Yeah, we'll put it in here. Let automatically go, and we'll say okay. And it's going to run the raw computations on those elevations and give you this report. Tells you a bit up here in the header business. And here's our closure results. There's our starting point, and there's our reference point that we're to close back to, our ending point number 5. There's its raw computed coordinate position. It's supposed to equal 0.1, and it gives me the direction of the error. It's my azimuth of that error, how far it missed in the north, how far it missed in the east. I have no vertical misses. So horizontal and slope distance errors, again, are equal because we have all 90 degrees zenith angles. For traverse lines, so we have one side shot. I didn't think we had a side shot. We'll look at that in a minute. We had a store point record. There's our total distance. Now here's our overall closure, 1 in 21,000. Now back in the old days, if you got over 20,000, that was a pretty good traverse. You said Yahoo and went home. But that's really kind of rough. So here's some more results. We had a backslide azimuth of due west. And here's again just some headers here as to what we had entered. And that's actually should be out here, but so point number 2, an angle right of 180, a zenith angle of 90, a slope distance of 100, instrument height of 0, rod height of 0. So these are, point number, horizontal angle, that's our headers. And these are the computed coordinates, 5,000, 51, 50, you can read all that. Now, where we have the error, you can see these are starting to creep in, which should have been 4,900 and 5,000. You see you got a little bit coming up into there, and then point number 5 also missed because we missed set our point number 3. All right, so yeah, here was it considered that point number 99 as a side shot. That's what got us with that one when we did the angle balance. Now, here's our checkpoints. Because we said trav 5 equals 1, it will just show you the comparison and then how much it missed by in the north and in the east and any elevation difference. Okay, now here's our horizontal distance of our missed closure, this 0.019. It says, okay, you've exceeded that horizontal tolerance. Remember, we put in as 0.01. So that gives us that little warning, and it tells us on line 9, occupied 4, slope distance, horizontal angle, zenith angle. So line 9, occupied 4. If I exit this and come back to it, line 9, it's this one right here. That's where we had that checkpoint located. And if you had multiple checkpoints, it would report those down there for you. All right, so that was our raw process with no adjustment. Now, if we just adjust the angles, our next step is our process doing angle balance. So we're going to keep these same settings, averaging multiple measurements. And again, it won't apply to this particular file. And no geodetic conversions there, report output. So that's basically that very same thing you saw in the process options. And again, we're going to close back to point number 1. We'll say, okay. Automatic, choose that. And now we have this closing angle. So it measured a closing point 5 to 99 and the closing bearing of 89, 59, 58. And it computed that as an azimuth here. But let's see, our reference closing angle should be. There's that 2 seconds that we missed. And from 5 to 99. So we report it as a bearing. It used to put those bearing headers up there. I'm not seeing that in this one now. All right, so there's our amount of angular error. And if we say okay to that, it's going to recompute that again. Here's our closure results before the angle balance. You saw that in the last report, 1 in 21,000. And so, and again, it shows the raw coordinate computations. There's an angle. Now here's the angle balance section. So it gives us the checkpoints like we had before. And now here's our angle balance. We had, no, I've got something wrong with that. Should be 2 seconds, not. There's angle balance again, 1. Point. Oh, 5 to 99. Reference closing angle should have been 90 degrees. Closing angle. It still should be 5. Let me see if I've. Yeah, okay, 270. I'm going to put that in as an azimuth. I don't think it should be. If I'm 5, looking at 4, I should turn 90. It may have to be as an azimuth. All right, so that should be my reference closing angle. So that's what it should be as an azimuth. If I say, okay, now my angle balance, yeah, there it is. 2 seconds for 5 sides. And so that's going to adjust each angle. Now, again, if you consider this data that we started with up here, all of our angle or all of our error is in this one measurement, this 99.8 and an angle right of 269, 59, 58. But what what happens in reality is, you know, that's actually a single measurement bust, but we assume that the errors that we are adjusting out of here, that everything was done within reasonable tolerances, and any of the angular error that we encounter gets evenly balanced through. So that's why it's taking 2 seconds per each of those traverse sides and adjusting each angle by 0.4 seconds. And then that would bring you back around. But the distances now have not been applied. So we still have this particular distance. So now our northern miss is a bit better. Our easting is still 0.019. And so now we've got not much of a change, 20,588, as opposed to, what did we see it up here as? $20,990. We actually made it worse by just balancing the angles. Okay, so in this case, you would, in our particular data, which is kind of bad data because it's all in one leg, then we would distribute the angles throughout here, but it made our precision a bit worse. Okay. So you could go back to no adjust to take that angle balance out. In our particular case is what we should do because of our angle being all in one particular spot. All right. And then if we go then to do a simple compass rule adjustment, our reference closing point is point number 1. Again, these settings like we had before, vertical error. We don't have any vertical error, but we could apply some correction there. And to adjust the vertical errors, do you want to apply that angle balance? Again, it would distribute the vertical error total balance through all the measurements. We don't have any in this case. So now we get back here to our any unadjusted points, report to sides, and then 3 point and report to adjusted points. We'll say okay, 1 to 5 again. Here now is the results of the compass rule adjustment. So there's our original from our raw. Here again is the angle balance report, and then our adjusted comparison. So you can see we don't even see it show up in these adjusted elevations. Of course, we didn't have any differentials. So here's our compass closure. So now we've got some, again, slight differences there in these last 2 points. Our maximum adjustment, 0.02 200ths, which again, in the old days would have been fine. And now our final coordinate values, you can see over in here. So our point number 2 is not 5100, but it's 0.995. You can see those differences as well. Okay, so that reported. Then I'm trying to find the we should compute after the process a new closure. I'm not seeing that reported here. Are you all seeing the same report? Do you have a closure at the end of your report after the adjustment. Let's see if it's hiding somewhere else. Showing me that here. Reference point is 1. You don't see that. Are you all seeing that? Somebody look at your report. Do you see a final precision at the end?
No,
Yeah.
No,
All right, well, I'll look at that over lunch. We should be seeing it. It should show us the result, see our closure. That's what I'm looking for after this. It does give these coordinates, but it should still report a precision, and I don't see that.
I guess
There it is after the angle balance,
kind of near the, okay, that's what I found.
but there should be also after our compass. Well, no, after the compass will adjust, after this closure, that actually closes it back to flat. Yeah, because that makes 5,000, 5,000, because we said it's the same as 1. All right, so yeah, that does make sense then, because it doesn't show you that. It only shows you after you've balanced the angles, but before you've made the adjustment. So once you make the adjustment, your closure is flat. It's nothing, because you're closing back to what it's exactly supposed to be. All right, so that makes sense. All right. So that puts us at 12. We said we're typically running a pattern here. I see we're always going 15 minutes beyond what we say. So anyway, we'll stop for lunch. And let me pause our recording now. Put the recording back on. I had neglected to start that back up. So that was just basically a step through on what we looked at before lunch. So if we open up this raw file 2 and take a look at this, now you notice there's a lot of additional, I'm going to hit this zoom extents. There's a lot of, well, not a whole terrible lot, but there's a bit more additional information. And when we see these DS records up here, that is short for description, and that means it's a note. It's just text. This is where you might, put in the average, your average temperature, things like that. So here they stored point number 5,000. Over here you see it, and then 5,001 is hiding down here under 7,001. It's in there. You can just see that little bit of yellow. So we had those 2 points stored as their starting 2 coordinates. entered an HI. And it's assuming, because I don't see any HR records in here anywhere. Not sure what, the rod height is this secondary column over here. So on my backside records, they're using nothing for the rod height. So that is not sure if I go to down here is where I'm setting the rod height. It's an HI record type height of instrument, but here's the rod. Oh, here it is, the 495. So 547, 495. There's my backsight 5001, this point here. Backsighting 5000, those are my original stored points. And then I start traversing my way around. And I've got some side shots here. So my first traverse point is setting 5002. And then I go to I'm sitting on 5001, looking at 5000. We've already set the traverse point of 5002, but we also picked up a number of these side shots. So now we still keep this backsight record, the same backsight, but we change our rod height to 1.6. And then we set 3001, okay, which is one of the side shots. And I've got them turned off down here. If we turn those on, you see there's quite a few side shots that were taken as we did this work. All right, so then we set up again. So we not only changed the rod height, kept the HI as 5001, but now we've got, we're sitting on 5002, looking at 5001. We had an instrument height of 514 and a rod height of 495. Now this rod height here at 1.6, it's less than 2 feet tall. So who knows what that might have been. It might even be an error, and you'll see that get flagged in a processing report. All right, then again, we're changing our rod height from 495 into 540 as we start collecting all of these side shots. Now to 0.35 as a rod height, you know, maybe they're turning the rod upside down and getting something down near the ground, who knows? But again, you'll see those flagged if they're outside of that range. All right, so this is fairly, you know, a little bit more typical. So if I choose my graphics pointing cursor and I click now this cluster of points, I've got those 2 points, 5001, 7001. If I go to 7001, I notice over here with my equals key character, that's going to equal 5001. So that's saying 0.7001 is supposed to be that same 0.5001. So it's going to use that to make that adjustment. Notice it is also over here a CL plus AB record, which means it's a closing shot and an angle balance shot combined together. So if you're traversing your way around, you're sitting at 5005, backsliding 5004, and you turn into what you suppose is 5001, which it is, and you're going to call that temporarily 7001. You're saying that's my closing distance that ties back in. That should compute this closed geometric figure. Now, again, as we talked about this morning with those little sketches, that's not going to be able to accommodate or correct for any scaling issues in the distance measurements, because that figure with keeping the angles the same, if the scaling is say 50% of what it's supposed to be, it looks the same, it closes back on the same point, but it won't be able to calculate the distance adjustments correctly. You know, we should have tied back into some different point from over here instead of back to the same point. And in addition, because we closed in here and we're using that for an angle balance, you would typically need to know what that is supposed to be. As I turn this angle and we're saying that 7,001 is really 5,001, you need to know what that angle is supposed to be so that you can balance the angles on this closing shot. Okay, and we don't have that information. You know, whoever made this file should know that information or something, because, and you'll see that when we run the processing bit. All right, so here's an example. I was telling you about, you know, your temperature, pressure, what prism number you're using, what date and time. Okay, so that's an idea, you know, things you can just add notes right into that as you're working. Do it in the data collector, or you could come in there and do it manually if you were building this file manually. And then we got a bunch of these side shots and off you go. Now, this point down here, 5006, it is set as a traverse record. It's 5001, looking at 5,000, just like when we traversed this around. We ran up here and it's called a traverse record, even though it doesn't tie back into anything else from here. It's not part of this network. It's just setting a point out here. And the reason it's a traverse as opposed to a side shot, if you look at the side shot records, it is used to set this point 4007, which is a side shot, and then also 4008, which is right there nearby. If I zoom in. So the only reason they set 5006 out here was to be able to set 4008 and 4007. Maybe you couldn't see those points from that last setup. So sort of a fly leg put out on our traverse. All right, pretty typical type of work. All right, so then when we process this, again, you can look at those no adjust records, and our closing point here now is supposed to be 5001. And we go from 5001 all the way around to our 7001, which is that same point. We say, okay, here it comes in a closing precision of 1 and 138,746. So not too terribly bad. And here are those warnings. Rod height 1.6, 0.35. These are the ones that were all invalid because they were outside of this range that we set. And all that is, you know, we could look at that and say, well, yeah, it is outside that range, but it is correct. Otherwise, it will tell you about those warnings, and it says at row. So that's the line number in the spreadsheet editor. And you could go and correct those, like maybe it got mistyped at the data collector. All right, so that'll help you find where those are. And again, here's your reference 5001. Here is the computed 7001. And there's your difference, 5,000ths in elevation, 1,000th in easting, 5,000ths in northing, or a total of 5,000ths in horizontal misclosure on that. Okay. And line number 122, the occupied point at 5,005. A particular record 122. Yeah, that's just showing what is our closing observation. So there's the information we had for our closing report. So now if we do look at the angle balance, again, 5001 here, go automatically. Now it's measuring this closing azimuth of 347.3305. So again, you would need to know what that is to be able to figure out, because right now there's, it assumes it for as 0. If you don't put anything in there. So 0, so this angle over here is that 12 degrees, 2655. But let's say that's supposed to be, say, 347, say 32.58, whatever it was. Again, we don't have that information for this example. So there is your raw precision. Again, your warnings. And then after you compute the angle balance, it finds it needs to adjust each angle by 1.4 seconds, which results in a worse precision of 97,690. So, that whether or not you have that value would tell you whether or not, when you're going to do the actual adjustment, whether you want to balance the angles. All right, so now, by the way, when we're doing the adjustment does correct for the angle, or the angular misclosure around these throughout the observations. It takes part of that into account as part of the compass rule. But applying the angle balance, this actually distributes the total angular error evenly among the sides before it does the adjustment. So, but again, you have to know what that is supposed to be, so you know how to calculate the misclosure. But the rest of it, when it reshapes all of this based on those distances, it does adjust the angles between them as well. So, and again, you can report the side shots if you want or not, and say, okay, again, 5001, there's our raw precision, which would tell us, yeah, we're good enough to come home. We've got this adjustment here from our compass closure. And so here's our individual traverse points. And description down here in this line, the second line down. So that's our first line header. So point number, horizontal angle, zenith angle. And then there's our description of each point. Okay, so there's our 7,001 equals 5,001. And we also had this, remember that was our fly leg that was out there as part of that traverse. Okay, I mean, part of the traverse records, but it's not part of the adjustment. The adjustment ended with that closing shot here. Okay. So once that's then computed, you can, accept these points. When you get out to save this, it asks you want to save that coordinate file. Now on the tools menu, we don't have any in this particular set of data, but if you did your direct and reverse observations and turned sets, you would run this direct reverse report and reduce those observations into their averages, or however you set it up in your processing options. And then now this update raw from points, if you do that, that means you've got points stored in your coordinate file, and it will come up here and change those PT records up at the top where we put in 5,000 and 5001, it would update those based on those points and then recompute the total. So that's one way. If you've gone out here and you've done your work, you started in the, you know, the 5,000 coordinate space, but then you come back and you know what those really are, you can just simply put those points in your coordinate file and then update that from there. That will take care of that in this and recompute all those coordinates. Sort of like doing an alignment with this to get it back into that new coordinate space. Again, applying field to finish if you like. Now, here's a couple of tools that could be helpful in this find bad angle. Now, that makes the assumption that all of the angles are equally good except for one particular angle might have been mismeasured. And if you find that, again, we had that reference closing point. We'll say, okay, so what this will do is come in here, and again, it's much like doing the angle balance, but let's say we knew that that was supposed to be 347. What did I say? 3258 as an azimuth. So 7 seconds there, but it tells us that we have a potential bad angle at our setup 5001 where we set 0.5002. So it took it as that first one. And we don't have that information, but where the way it calculates this is when it looks at this figure and it looks at the initial raw report, and we have this azimuth right here, 187.0840. If you have in a figure and you look at the closing or the misclosing line, let's look at if this were, let's say if this were our closing that we expected, and that's how much we missed it, and that's our misclosure. Now we're obviously it's much smaller, but it looks at the azimuth of that misclosure line, and then it takes that and puts that azimuth at that line at each of the angles of the figure. And if it's perpendicular to those or not perpendicular, but if it bisects most closely the angle at that particular setup. So if this is over here, we would expect it to be over here if it's supposed to be on that same line. So it would take that particular misclosure and look at, let's say if this were the bad angle, everything was good except for this one, then it would find that angle that you need to correct. You would correct that angle. You would go back and maybe either re-observe it, or if you entered it wrong from a field book, whatever, you could, aha, I've got the wrong number. That's not so much a condition anymore, where we're not going to be entering stuff from our field book, but that would tell you which one of those individual errors to go, or angles to apply that to. So that's not necessarily going to be magical and always work as the golden solution. That's just to help you find a particular given one observation. And then of course you can combine other raw files to keep building into this. You can draw the side shot lines, and that means draw them out here in the drawing file. Renumber your points, etc. Again, you can set a separate coordinate file. You can create point groups based on descriptions, etc. All right. So that's basically that part of it. Let me make sure I reapplied this. No angle balance. I will say okay there. And now I've computed And when I exit, it's going to ask me to save the coordinate file changes. I'll say yes. I'll look at my points and I'll see that they're all there, including all those side shots. Okay. And then of course you could, let me make sure I turn that off. I don't know why it keeps resetting that for me, but anyway. So now I've set that. Let me make sure I've turned that off. And then when I draw locate my points, you can see there's, there are traverse points in there as well as all of those side shot points. Okay, that came out of that process. And these are those adjusted coordinates that you're seeing here. Here's that 3190 that was used again as a fly leg. It was coded as a side shot, but it was used to be able to set these other side shots from there. Okay. So now, let me clear the decks on that. In fact, I'm going to erase all my points. Let's just say by number all. Yep, take them out of the coordinate file. Confirm, yes, now they're done. So if I look at yet another one, and this is not set up for this particular type of adjustments, but here's one called North Line 6. And if I look at that, it's going to take a little bit of time to come in. And I can see with my, even with my side shots off, now if I turn my side shots on, you can see there's just a slew of observations here. And there's a lot of doubled up observations. And you can also see, if you look at this, here's a closed network of points. Here's another closed network over here. They're tied together. So this is a multiple network traverse, and this is set up to do our least squares processing to tie these multiple networks and multiple observations in together, adjust everything so that the sum of those residuals is minimized, or the sum of the square of the residuals. Okay, so let's take a look at that file over in our least squares processing. Oh, by the way, before we get to that, I'll just show you this edit process level data. Have a file called level data. And what this is, it's not very much. It's just a simple, we have level records, level start, turning point, the side shots, and the end record. So start record, turning point, side shot, just an LV, and then an end record. Okay. So you can see we've got these particular points, and this is just computing levels. And it does this. This is just like you would do in a field book when you measured all these up and you do your page checks to calculate that information. That's really all that part does. If you adjust the elevations, all right, so I've got a measured closing elevation. What is it supposed to be? Well, let's say it's supposed to be, see, we closed on 0.8, 101.5, maybe that was, 101.3 or something. And so when we do that adjustment, it takes those and just simply applies that just per record, it spreads that misclosure amongst these elevations. That's really all this does. These are the actual the readings.
Ken, where did you find that? Where's that level editor?
Yeah, this is right below, let's say no changes. This is right below edit process raw data. This is for your level data. Now, if you're doing your elevation gathering by trigonometric means as you traverse, you wouldn't really do that. But this is if you're running separate level loops. And you could actually, even if you've already got coordinates in your file with computed elevations from trig runs, you could run levels through it and then have this adjust the elevations only. That's what that would do when it said update coordinate file. So this is, well, again, let's look at that and then look at settings here. See, if you're using three-wire leveling, you can again put in your tolerances to see if something's in or out of those particular tolerances. See what else we have. Levels. All right, until adjust and then store to the elevator. And that's really all that it does, is it basically puts those in. Now, if we have three-wire records, you can add I'm not sure exactly how that, see, this is 0.1. This is my back side, HI, my force side. So sitting here reading 5, these are my rod readings. Sure that. All right, so here apparently if you're using a TLV file, it can also contain trig level data. And it has different records. It's got benchmark. It's basically your store point. And then here's your rod height if you're using trig, if you're doing trig leveling. Set up your backside and then how you set your differential up, either a vertical difference and a horizontal distance. So that's for our trigs. But if you're using this, if you're using 3-wire, and this particular data is not 3-wire. So if we did a new one and we chose, let's call it test, we have to choose here basically from, I don't think we set it here. It's just tolerance values. So if we set our we had a point number, say 1, we knew its elevation was 100, for instance. And let's see, do we have to? We have to be in the description field and hit enter. No, hit tab. Tab will bring us down there to it. Okay, there's their benchmark. And then we would put in a backside record. This will be 0.1. Foresight. Let me go, I'm not really sure about that. If I'm doing 3 wires, here's an example. So those blue cells are the ones that it calculates. So I've got a point here, my start record. I'm reading 5.3 on that BS column right here. And its elevation is 100. So we typed that in as an elevation. And then we went through these series of turning points. We had point 7. And this 6 is this distance here. And 0.7 is just that differential there. Then we look at, oh, I see that 0.7 is, it's in this column called BS, but that is the following reading there to say 0.7 and then 1.0 over here. And let's see what else we showing that there's our 6.71. So 6 here, 0.7 and then 1. And this just continues on. The sketch doesn't go any further. So, and that's for a single wire. And here's for your 3-wire level. So there's your top, middle, and bottom wire readings. That's what you're looking at in that first set of columns. You know, the back and the forth, the back site and the foresight, the back site and the foresight, and then we'll compute these as well for you. So you get down into these turning points. You would enter in adjusted elevations here if you happen to know them, and it would use that to apply to all of these calculated elevations on the interior of the level loop itself. Okay, so there's a start turning point level and returns. Yeah, so a single wire, just a single wire level loop, it just averages the number of turns to spread that error across those. If you're doing 3 wires, it proportions the corrections based on the distance between those measurements, or the spread on the wire will tell you that distance. Okay, so and then adjusting the coordinates. Point must match. If it matches a point number in your coordinate file, then it takes those adjusted coordinates and applies it to the CRD file without touching the X and Y. Okay. And then it will report if it didn't have a match on different ones. All right, so there's your backside rod reading, the calculated height of the instrument, foresight rod reading, and the elevation of the point. All right, so it's pretty simple, pretty straightforward. We don't really use it a whole lot anymore in the days of, you know, most of us have automatic or digital levels, in which case that's all taken care of for us. But if you don't, you can enter that data in here as well to get, you know, to apply the level run elevations that you get, or if you're using just simply trig levels from your traversing and side shots, it gets computed in your raw file processing. Okay. Any questions, thoughts? What do you guys use? I would guess predominantly you're doing trig levels with your total station stuff. Or do you run level loops still?
Mostly trig levels, certainly the situations where we need higher order control, where we use levels and add it to it.
Okay. So that would be the time at which you could process that, or if you're using, you know, a pretty high precision level, it's probably digital. I'm guessing you guys use digital levels.
Yes, we're mostly using digital levels for everything.
Yeah, okay, so all that stuff is really handled outside of this, but this is that little routine that basically just applies an averaging across single wires, or you know, it's not a hard calculation to do by hand or with a spreadsheet separately, but it's included here with you as part of it. All right. So let's take a look at our least squares routines. Now, this is going to come up on mine and prompt me that it can't find that North Line 6 raw file because it's set in those settings from the last time it was run. So I'm going to show a new folder location to find it, and it happens to be right here where I am. So I'll find it there. Then that should update that location. So now when you run this, I'm guessing you don't get this control panel. Is that correct? I'm guessing you probably just get this. Let me see what's going on with that. Why is that even up? Shouldn't be. Okay. All right. If you choose that on the survey menu, your ServNet adjustment, do you guys get this control panel?
What did you pick to get that? I missed that.
It's on the survey menu, ServNet least squares.
No, we get a different dialog. We get another window that pops up.
Yeah, you get that.
ServNet startup.
Yeah, so you'll get what basically comes out down here under tabs. You'll get a separate windows. And I don't even think the 2021 version, although my license number is beyond its expiration date on that, so I can't really show you that. So this being the 2022 version, this is a pretty big difference, although everything's the same. It's just you're going to have different buttons and different menu choices to set these things up. So this is basically an interface here where you can add a raw file in. You can also do that here, add and subtract, and close. I've got settings. I'm not sure where your settings are going to be, probably on the first pull down menu.
Yeah, it says filed and it says settings.
Yeah, okay, so when you get to that, it probably looks like this now.
Close.
Yeah, is Tom, or are you on at this point? Does anybody know if you can see him? I don't need him. I just wonder if he's here. Okay. You guys probably, if you, do you use this ServNet processing in your work now? Are you guys using this?
I don't believe I think most everybody's using the least squares adjustment that Carlson provided, not this ServNet.
You say that Carlson provided?
Well, that's in the survey the survey pull down for these squares.
Oh, I see. You've got, yeah, see, I don't even have that in here. You've got the old process lease squares.
Right.
And that the difference between those two is nothing more than this. The ServNet allows you to use multiple networks that are all tied together, whereas Carlson's is a single network adjustment only. Let me see. They've taken it out of this version. I don't think this SDMS.
So what I'm talking about is when you go up to edit process raw file, you go over to process compute and you come down to least squares and process least squares data through there.
Like this. There we go.
Yes.
Okay. All right. So let me find that here. I wonder if it's.
I mean, other people may be doing it other ways.
No, this is absolutely fine. And if we load up, well, it's not going to work, I don't think. Maybe it will, because this is a multi-network. Let me see. Compare the data. Well, I don't even know what is in here. Let me. I'm gonna close that file. Let me open that raw file too, because I know what those numbers are supposed to be. And then if we do this, all right, our reference closing point is 5001. Oops, let me see. Yeah, daggone it. All right, so here 5001. Let's go ahead and let's go. All right, so okay, so now these are my measurement errors, and they're basically start off seed values. So I'm going to say I'm going to measure it within a second, and my pointing errors, how closely I could point those to within. All right, I'll just take those defaults there. Centering error, instrument centering error, that's how you set up over the point. And this number right here, this EDM constant, that's going to come from your equipment and your scaling parts per minute, or I'm sorry, parts per million in your scale error. So those numbers right here are going to be instrument specific. And that's why I was wondering if Tom was on. That's going to be something that you will get from your equipment information. They should tell you if you ever have your equipment calibrated, they'll give you new numbers for that, or coming out of the box, that'll be listed in the documentation. And then you can load and save different files. But so that sets that part up. It's going to traverse accordingly through that. And again, we don't know, that was say 347. So we've got it 3258. Give me valid rod height warnings. Now it adjusted my elevations. Here are my control points that I set up. That was my closing. Those two are supposed to be the same. You see, they put them back at the same. And then these are the points that got adjusted. Here are the actual observations for distances and for angles. That's my process results. So that actually did the processing I prepared the data. Now I can edit the data, and that's going to set up my control points. If I take 7001 out, it's actually supposed to be, that's the part that drives the adjustment right there, because those 2 points are supposed to be the same. Let me, so 450578. Let's come back up to, all right, so 450578. So that's what that's supposed to be. Now, under my data, I see that 450578, and it says 7001 needs to be 450578. That's what drives the adjustment. So it knows that that has to be computed to make it into 5001's same coordinates. I don't think if I, yeah, if I were to remove that, it's not, let's see if I removed. Yeah, so it can't remove it because I'm taking care of that. That's what it uses to calculate that difference. Then again, here are the coordinates for these. So if I have known coordinates for any of these other points, maybe I'm traversing through another known point, I would add it up here into my control point as well. Here again are my distances. Here are my angles, and it lets me, let's say if I wanted to edit that record, it just lets me, adjust those kind of things if I had. And these standard errors are the computed, that's a computed value, but you can edit those if you have any particular reason. And then again, my angle measurements as well. And then if I look at the angle error, again, because I don't have a good closing reference, so that's why that's going to be some goofy ass number. My distance error, 0.035, and that's a standard error. That is my, that's a statistical difference. Right. So that's now setting up the data. Now we haven't actually done the adjustment yet until we come down here and process that information. And we'll report that. I'm not going to report the side shots for right now. If I draw my error ellipses, oh, didn't converge. I don't have enough on here to converge it. I think it's because we're missing that angular misclosure. All right, let me open this one and see. I don't think it's going to let me do this. Oh, see, I don't know. All right, let's say we started on 1 to 2 to 3. Came around this loop and ended at 1. Now that went 2 and then it went this direction. Yeah, I don't think I can show you that with this file. Closes back to here. All right, so 1 to 2, 7, 8, 7, 9, 10, 11, 12. Right around to probably 48. Let me see if that's correct. It's 47. It just comes out here, right? So 43 to, if I close back, so 1 to 2. What are the points that I've got right here? 164. Now, see, 2 took off and ran 159, 60, 61, 62, 63, 64 to tie into this. Let's see if I can find a particular loop. All right, so I'm storing points number 1 and 2. So that would be my store points. Change that color for a side shot. Side shots are green. Let's make notes. Make it magenta. There we go. And can I hide the descriptions? There we go. There's a hide. And then if I hide side shot records. All right, now let's see if we can figure out an actual traverse. So I've stored 1 and 2 right here and here. So where I could store my reference azimuth in my standards. But that only works with ServNet, those records. All right, so if I come on down, I'm not going to see, I'm pretty sure. Yeah, I don't have any kind of a closing shot or angle balance shot. So I can't process this like a standard traverse. I'm not tying that in. I'll check with Tom. So here, let me see, maybe. Yeah, there's no raw file in that. Let me go back to there. Okay, so yeah, I can't show that with this data because it's multi-network. And I'm trying to see if I can get this little raw file here. I don't have that. Let me see. Prepared the data. 1001. One second reading error. For a second, these are all reasonable. See if I can get that to, let's just do 5 seconds total. All right, there it is. It didn't converge because of that angular error was too big to start with. All right, so to back this up, if we load up our raw file 2, and this was our, we set points 5,000 and 5,001. That was our initial backsite. We turned this around and closed back on ourself. Come through here and do our least squares processing. We look at the prepared data. Our reference closing point is 5,001. We'll say okay. And these are our standard errors. 1 second of reading error, 4 seconds of pointing error. Target and instrument centering over the points 200ths, and then a 0.02 EDM constant and a 10 part per million scale error. Then it asks us what the traverse starts and ends on. So 5,001 is where we start. We end on 7,001, which is supposed to be the same as 5,001. Say okay. And to be able to make that adjustment, it needs to know what is the expected closing azimuth there. And we'll put that one in as 347. 3, so we're within 5 seconds. So that's, we had it as 3258 the last time, and that was too much of an error spread to make this solution converge. So we say, okay, now it's going to give us our warnings like we saw before. Here's our checkpoint, 5,001 to 7,001, the computed raw value compared to what they should be. There's our delta. And then there's our adjusted elevation comparisons. See what they originally computed to what it gets adjusted to be and what the delta is. So those are pretty good. There's our control points. So 7,001 is supposed to be this, whereas we saw up here above that it was this. So to be able to adjust back to equal 5,001. And these are the points then that got adjusted, 5,002, 3, 4, and 5. And those are those adjusted values. If you compare those to no, we don't get a, we'd have to run a raw, no adjustment computation, then do the comparison. And then it just lists for us the distance and angle observations. really understanding that value of 90 degrees. $5,005. Back to the start. It shouldn't be that number, but I'm not sure what that is telling me. Because that's from here up to here. It has nothing to do with north and east. All right. So did I compute the side shots? Let's report them and see what it says. And draw the ellipses. No, it's trying to. It's the side shot data. Well, I may not have data that's going to be well suited to show you this. Let's see. Yeah, see that right there. Causing the misconvergence. I think it's because if I, let me see that, if I edit the data, 5,000. Yeah, it's this record right here. I take that out. Let me see if that then. Oops. It applies that across the board. I think it's going to blow our angles up. Let me see here. No, still not. That error there was yeah, see, I've got these different standard errors for angular error. That's fine. That right there should not be an observation. But there's a store point. Um, There's 5,001 to 5,002, 2 to 3, 3 to 4, 4 to 5. So 5 to 4 is my backside. Okay, there. It doesn't 4 to 5,005. And that sets the fly leg. I think that's the last observation. That ties back to 3190 to set this one. Yeah, yeah, this data is not. Let's show the record, show the side shots. See, it's calculating that line right there as an observation, which was never made. 2 to 3, 3 to 4, 4 to 5. No, from 4, oops. From 4, 5,004 to 7,001. It was at 5,005, backsliding 4 to 7,001. Then it's from 5,001, looking at 5,005, closing an angle of 90. It's not pointed at anything. I should be simply able to do that. Yeah, I'm still not able to converge because of that angle. All right, well, instead of wasting a lot of effort on that, if I had a better file to show you here. Let me see if I've got one handy. Yeah, see, I think this is still multiple network. Yeah, so that's still not going to work. What if I choose traverse 1? Traverse points. We stored TR1. We stored TR100. So TR1 backsiding there, we set TR2. Tier two. So this is good multiple observations. And then we set tier 1B. See if I've got any name records here. See any. Let's try traverse 1. Closing point. Should see a close record. Try finding this. Oops. I'll turn it on. If I close, right there's the TR1. Sitting at 2. Observing TR1. One, 2, 3, 4, 5, 6, 7. B. So it's 100. Let me see if I can just try a guess on this. I don't see any close records. There's a name. That's where traverse, that second traverse is SS Trav. That's where it starts. And that is TR7. All right, let's try that one more time. We'll prepare the data. Traverse 1. Assuming 1 to 2, 3 to 4 to 5 to 6 to 7 to TR100, I guess. I have no idea if that's going to work. I don't think we close back to ourselves. Yeah, let's see if that'll fly. All right. Look at our data. There's our 2 control points. Distance. Pretty good standard errors all the way down. Angles. We got some, wow, look at these nasty TR100 to TR1 to TR2. Let's see if we process this. All right. Yeah, I didn't think it was going to converge. It's these. Don't know why they're being so large. Let's see here. Did I get them all? Nope. Oh, this is ridiculous. Yeah, let me see. We got that one turned on. Well, they sure need to work on that interface. And hopefully this will be the last it will require, although I still think those standard errors are going to keep it from converging. All right, let's try that. Yeah, it's still not going to work. Well, in any case, don't have any good data to show you with this Carlson least squares. And again, they've taken that completely out of the menus at this point. It used to be, it would edit process your the Carlson least squares, and you also had the choice for ServNet. So I'm sure that raw file, yeah, it doesn't have anything. In it at all. All right. Well, let's move ahead on that. If I can find something tonight that can illustrate that a little better, I'll bring it back for tomorrow. I think. These are just ones that turned on. See that this is set up, it's a multiple network and it's set up for this tutorial for ServNet. Take north line in and add. Let's do that. And ServNet tutorial. All right, so the process took 29, it converged in 2 iterations, so that took care of that. There's the adjusted network drawn. Withdraw error. Error ellipses from TR1 to say TR7. All right, it's a relative error ellipse. Draw the traverse points, draw the side shots. The error ellipses. And there's our side shots. And if I zoom in, there's our error ellipses. That's what I was looking for. Okay, now when you guys process your stuff using Carlson's least squares, are you drawing, typically, do you draw your error ellipses?
No, we don't do that.
Okay. So really all that is it gives you a means of, when you're in this in the multi-network processor, is it shows you the position within which, you know, that's the confidence level in which that point lies, anywhere within that particular drawn ellipse, and it has a certain orientation. So what that gives you a little bit of a measure of is, in this case, you see TR7 is sort of along this axis. And so that's there's more likelihood that it's going to lie along that direction than, say, this short direction. And ideally, those things would be, you know, pure circles. But what that would tell you is if, let's say, TR7 was set by an observation that came, you know, from this, whatever this point back here was, to set number 7, then maybe the angle that computed this line to compute this point, you know, maybe the angle is more, well, let's say less precise, or there was more adjustment to tweak that angle. There's more flop in the angle. Say if it was coming from that, if it's coming from this one, you know, the angle is not so much, it's more along this direction if it came from here. So it's probably a distance thing that's pushing it more this way. And of course, you see it does have some angular side, but that sort of gives you a indication of the, and here's, for instance, TR6 was set by this line from TR5. And so the angle is really what's pushing that more so than the distance. Okay, so, and then of course you get, you know, all of the statistical, there it gives you error warning, see the tolerance. Basically all of these different, here's our different error results. And here's our final adjusted coordinates. So the real, I guess, takeaway to consider is understanding that all of these points are computed based on these observations, you know, multiple observations, distances, angles. You could have GPS observations, level files that adjust the elevations if you had those with it. Control files, certain points might be check-in, you know, hold these points sacred and don't adjust them, but that's what we're trying to tie our information into. And so the process of adjusting something through a least squares adjustment will give you the most rigorous adjustment of that. And like I said, I don't have any. It's going to be some kind of error there. So I don't have anything set up to use that, the older Carlson least squares adjustment. And you can even use this ServNet least squares adjustment with single networks. That part's fine, but what it's doing is that you put in some starter seed values, those standard errors. When you put those in, it's to the amount of expected error that you're going to find by pointing the instrument, by how much error there might be in centering the instrument over a setup point. Same thing with the target. And then any of the instrument specific errors, the scaling factor adjustments, that's the part per million, you know, and any of those kind of limitations that come out of that, either out of the equipment manufacturing literature, or if you've gotten your equipment recalibrated, those should be recomputed and you should have those records to set that up in the control for this adjustment. Okay, so without getting too much further bogged down in that, let me see if there's anything in particular to talk about here. There's that little example. There's this one. Look at least squares in the next exercise. Are in here. So if we set this up, now this was ServNet. That's what we just saw there with that multiple network. And that will step you through this. And it says it's, you know, it's really sort of the thought about it, all those numbers, it gets a little scarier than it really is. And really all you need is just understanding what goes into that package and what comes out of it, or a best possible adjustment, because it's going to shift those coordinate values by the smallest amount of any other method. And that's really, you know, what we're after. So this lets us, let me see what we did. We use raw file to okay, let's see. Processing tab. Sure my points are empty. Yeah, all right. Now it thinks it's already running. All right, so if we look at our we'll make a new project. We'll call this one test 2. We'll add this raw file 2. Okay, we're going to process that. We'll look at our settings for a minute. In our pre-processing, we have to set that string there to tell it 7001 equals 5001, just like we did in the other raw file processing. Compute closures. For blunder detection, we'll float 1. Works that there's a single blunder in the data set. It probably won't find anything. Nope. So then if we compute, let's close your file. And still did that. We draw it. Yeah, mess it up here. Gave me that test two closure. Let's go back and uncheck that for now. Say okay. Yeah, even that even that data is not well suited. It doesn't. It's got some spread on those errors. I draw, that's all right. There's my draw with error ellipses. Almost side shots. See, I have nothing there. That was a stored point. 5001's a stored point. There's that fly point. So if you were to see any particular point with these error ellipses, so there's one that's real close to being circular, which is a good indicator. Now here's one that is oriented more this direction. So that tells me that possibly this angle, because we traversed in this direction, so possibly that angle is a little bit weak. Yeah, there's a good one for you, good circular one. Okay, now in your ServNet processing, which is that next one down on the survey tab, this or survey menu, the ServNet least squares, you won't have this dockable control. And when it draws it in a floating window, which looks like this one here. And then you can elect to draw those results out in the drawing, which would be what you see down over here on this side of the page. Well, that's actually for field to finish, but so here's something to take note of when you're, if you go back through and work through these examples in the book. Right here, just make a note of this on the page, is that you have to revisit those tabs and reset the actual output files if you've got them pegged to anything, because they stay hard coded from the last time you ran it, no matter what drawing file you're in. So you want to make sure you revisit those each time you open up a file and do the processing. If you're working with that same file, you don't have to keep looking at it and changing it. It won't change, but it also won't change when you do a new one. Okay, so, and these are all the side shots and those expected spreads on the side shot. You can see the area ellipses on those as well. Okay. So let me close that, discard. And I'll go ahead and close that file and say no. All right. So take a quick peek at here. We're looking at, all right, some adjustments, field to finish, deed processing, coordinate geometry, lot net layouts. All right, so we are at a good spot for our mid-afternoon break coming up here. We'll finish up. We'll come back at 3 o'clock. But what I'm going to do when we come back is we're going to put field to finish off until tomorrow so I can take a look at your data that Tom sent me. And I will put those same files up on a download link when you get for tomorrow's meeting. You'll be able to bring those onto your computers. I'm sure you've got them on your network somewhere anyway, but this way you'll have them there locally. But let's, while we're talking about that raw file, for instance, let's do a little coordinate geometry work when we come back and look at some deed processing. And then tomorrow's work we'll probably do a good bit of field to finish, and then some lot net and some layouts and annotation, that kind of stuff for adjustments to parcels and such. Now, do you all have, let me see if I can close that. There we go. Do you all do work? 1 second, let me get back to that screen. Okay, sorry about that. Do you guys do like subdivision designs and things like that? Lot layouts? Obviously you do boundary retracements and things with deeds and all of that, but do you do a lot of subdivisions?
Yeah, we do a lot of subdivisions, boundaries. Subdivisions probably make up the most of our work.
Okay, I'm creating new ones as well as working within existing, right?
Yes. Yeah. Some of them are ongoing projects, phase 1 through 6 or 7.
Okay, yeah, good. So LotNet will be a good thing to spend some good effort on. Tomorrow, we may get into it a little bit today, but probably not. We'll go look at some coordinate geometry. Now, do you use the coordinate geometry tools to set point locations and such like that? Or do you mostly create things based on, you know, CAD distances, like drawing a couple of circles at different radii and finding the intersection point, or do you use a distance intersection command?
Both circles and radiuses from time to time, and sometimes distance and distance. Most of our layout is done using DXS. We don't use a lot of point creations or point layouts, but mostly using the DXFs.
All right, DXFs from other
disciplines.
yeah,
from our design group.
Yeah. Okay. All right. Now, when they give you DXF, is that because they're using maybe Civil 3D or something like that, or?
They are using Civil 3D. We bring everything into a layout drawing. It's a Carlson, but we bring all those entities in through either XREFs or copy and paste, or whatever method is that we use. That particular person uses to get them from design to the layout. Most of the time, it's a DXF.
Well, that's what I
an XREF rather, and we create the DXF for layout.
Okay, so yeah, XREF instead. I was just wondering why you're using DXF. If everybody's using AutoCAD, DWGs would suffice equally. You don't need to use DXF unless you need that for some other process.
I think it's just from legacy. It's what everybody used for the longest time, and everybody just continued to use it. Certainly, recently we started using a little bit more the DWGs because we're bringing in text and stuff like that more often into the layout drawings for use on the data recorders.
Oh, okay, I understand that. What version of CE are you using now?
I just installed the latest 6.12, I think it is.
Okay,
The most current version.
yeah, so you're pretty up to date on that, and yeah, CE will actually use DWG directly now as well, but it did in the past only use DXF, and that may be what got you into that workflow. But DXF still works. That's not a problem. But in terms of sharing stuff just within the office, computer to computer, you don't need to go through that DXF effort. You can just go DWG directly. So in any case, well, I said we just talked through part of our time. I'm still going to give you your 15 minutes. So let's come back at 10 after 3. And then we'll pick up with some coordinate geometry examples and show you how those tie into your raw file and what you might get some benefit out of tracking that if you do, to be able to go back and recompute things. All right, so I'll see everybody back here at 10 after. Let me.
Hey, Ken, I got a question.
Yeah, sure.
Do you have any information on doing a least squares adjustment with GPS vector data and how you would incorporate the GPS vector data, with your gun work?
Yeah, I'm not trying to see if I've got any example bit.
Maybe something tomorrow or.
Yeah, if I'm doing. Yeah, let me see what I can find out about that. If nothing more than just a place to steer you to that. It's not something that a lot of people do, and it's simply because the GIS data or GPS data that they do use, a lot of people, either through post-processing or they'll subscribe to a subscription broadcast service that they'll get the real-time corrections broadcast to them as they go. So that part's already done. But let me see what I can find on that to let you know about it. All right, so we'll take care of that. So,
All right, thank you.
You bet. All right, so I'll see everybody back at 10 after, and we'll pick back up from there. I just saw that in. Here somewhere else. Maybe it is of that form. All right, let's try that. Yeah, okay, so that overrides that thing that's previously set in the PGP file. If you set your quick keys up, there's one that I saw already done. In here. And I went past it and I didn't see where it was. Close as a new join. Let's draw locate points, LP. Well, it doesn't much matter anyway. You can set that individually, but the quickest way to set that is with the inverse command. You would just type I and go from your backside point to your occupied point, and it sets that for you on the fly. Really, I saw it right as I rolled the mouse and went past it. So there's enter and assign. But in any case, that's a way that you, if you're a command typer, if you don't like to pull them from the menus and such like that, when you go to use a command like erase by layer, look down there on the command line, it tells you LDEL. That's the command that would run that program or run that command, and you just put that into your settings file, this quick keys. You would add, just set up a whatever you want to type. And then if it is a Lisp routine, which that occupy point is, you need to put parentheses C:, and then the name of the command and close the parentheses. If it is an internal AutoCAD command, then you need to set it to this form. Parentheses C:, ACAD underscore command, and then put in quotes what normally is echoed on the command line when you run that command, and then close quotes. These other ones up here are the names of little ARX programs that would work. And there's no real way, if you don't know how the program is built, to understand which way those are going to work. But if you see a command on the command line, you won't see all of this mess. You'll just see _.dxf out, or you'll see cd _edit _bpf. What you simply do is you come down here and start off with, when you put a file in, start off with what it shows you on the command line. If that doesn't work, then try it this form first. If that doesn't work, then try it in this form by putting C:, ACAD underscore command space, and then put close quotes around the command and close it with the parentheses. And one of those three methods will work to set up those new quick keys. All right, so enough of that aside. So being able to do that stuff on the fly if you calculate a series of points, is pretty handy way to go. But there's also, if you aren't real sure about that, how it's working with, sort of heads down working, if you run this visual COGO and you choose any of these, let's say occupy point, you'll get this dockable control panel over here on the side. And there's commands up here: occupy point, enter and assign, inverse, traverse, side shot, distance, intersection, bearing, distance, your zoom in and out, pan, left, right, up and down, and then some settings for visual COGO. If you want to be prompted with or without the sound, prompt for any kind of a rotation on your bearings, etc., what angle mode to use. All right. So now you can also set snaps to be in play. And right now I have no occupy point, and I can just type a number. I can pick it from a list, or I can graphically pick it. So if I pick 3 as my occupy point, okay, and so now if I want to traverse from 3, I need a backside point here. So I'm gonna, that's backside point number 4. And then I can, if I have an instrument height involved, there's my backside azimuth or bearing, whatever I have it set up to be. But it calculates that. I'm sitting at 3, looking at 4. And so now if I want to calculate a side shot there, here's my point number. I can set a rod height. I can turn an angle right, or I can turn any one of these methods. It's bearings, 1, 2, 3, 4 quadrants, azimuth, angle left, angle right, deflection left, deflection right, or use GONS instead. I use my angle right. You can also use the calculator, and you can calculate the angle based on points, or you can do some math, and then when you return it, fills that out. But let's just go as a simple example here, 90 degrees to the right. We'll leave our zenith angle just blank for 0. And our slope distance, so I'm going to make that vertical angle 0. And a slope distance of 50 feet. Give it a description. We'll call this one test viz. Because it came out of Visual Kogo. You can create the point as an option. You can draw a line as an option. You can also preview missing occupied points. When did that happen? Did it not take 3, 4? Oops, 4. Traverse 12, 90, 50. All right, now if we preview that. Well, that's helpful. I'm hoping yours is working correctly if you're following along. If not,
I got that same error, and I'm noticing when I go to click my occupied point, it shows up as the letters PP instead of 3.
yeah, if you say occupy point, and if you just pick a point here, for instance,
Traverse point.
just pick something on the screen. Or in fact, let me exit this for a second and draw. I'll just draw this. So now if I go back to Visual Kogo, if I set occupy point, and if I turn my snap to endpoint, and if I grab that endpoint, oops, I want to select a graphic, occupy point, graphically snap to the endpoint, shows me that, and it says PP, and that stands for picked point. So if I'm sitting there and I set my backside point to be that one, calculates the backside angle, that's all fine. So now if I want to do a side shot, occupied backside HI, why is it not? Wow. We broke it again. Does yours come up with,
Yeah, I think you have to, when you go back to the occupy station
yeah,
and then put your 3 backside 4, then hit accept at the bottom.
that could be. Yep, that's exactly what it's going to do. Thank you.
Yep.
So then you can come here. It now shows you, even though I didn't pick a point number, it shows me my pick point and the backside is a pick point. So now I'll do my 90, say 50 feet test. And I can preview that. So I was sitting here, backsighting here. I turned 90 and went 50 feet. So it would set it out here, at which point, if that wasn't what I meant to do, maybe I wanted to do an angle left of 90, preview that. Okay, and then you can store that point. Okay, so yeah, that's a very good catch, is if you set this stuff up, you will, and now because I'm sitting there, I'm occupying that, still backsighting my previous place. Let's say if I pick 3, looking at 2. There we go, 3 to 2, accept that. All right, so now I'm sitting there, backsliding 2. And if I set side shot 90, sorry, I hit the wrong thing, 50. And you don't have to preview that. Let's see, oh, that's angle left again. Angle right's what I typically do, preview, yep, store that if I want. And now notice, because I did a side shot, I'm still sitting on 3 looking at 2. But if I traverse, and let's go 135, 100 feet. And that was also a CTRL. And you don't have to preview these, and you can turn on your draw line. Just go ahead and store it, and it draws that line for me. And it now has moved me up to 14, backsighting 3. So this might be a little better interface for you. It shows it to you visually. Okay, so, but that's really all it's doing. Now, let's suppose we calculated these things in and we said, oh man, you know, I should have set all these points instead of being 1 looking at 5 and turning these angles and setting that point, or 1 looking at 4, whatever it was. Maybe I should have been looking at 2 instead of 5. Well, any ways of doing that, I can't go back and recover that because my raw file was not on. But if I turned my raw file on, we'll make a new one, and we'll just call it Kogo example is fine. And so now if I, whether I do visual or by this command, I'm going to inverse, let's say 4. Just do inverse 4 to 1. All right, so there I'm sitting there, and if I set a traverse, angle right of say 2, let's go 285, 250 feet. Control and move that up. Now, if I side shot that and set, let's do another 50, or angle right of 50, a distance of 75. We'll call that one test. And we're still doing these. We'll say 125, 50 feet away, another test. And it escape to finish. All right, so now I've done that, but let's say I had that mis setup. So if I edit process my raw file, just like we were doing with the adjustments, and I now choose this Kogo examples, there are my results that I saved in this file. So I had a backside record here of 1 looking at 4. And then it went, then I set 15 as a traverse record. And then from 15 looking at 1, I set 16 and 17 as side shots. So in case this was the wrong one, let's say instead of 1 looking at 4, maybe I should have been 1 looking at, let's see, here I scrolled, but let's say 1 looking at 6 instead. Whoops, 6. Now, if I look at this in my graphics, that would set 1 looking at 6, and now my angle right of 245 sets 15 down here instead. So now if I think all I gotta do is just save that and exit. Now I've got to process it. Sorry, process, no adjust. I think I just hit defaults there, exit that. And now, see, 1 looking at 6. I don't know if I had to compute that or not here. And then I'm going to save those changes, and then let's redraw my points. So now those, what did I do? 15 and then 16 and 17. So now instead of what we originally had 1 to 4, we had 1 looking at 6. So if I go to 6 to 1, and then came up here to that, and then if I look at this angle, set my units up. Sorry. So what was my raw file? Angle right at 285 degrees. And 285 plus 75, that might 360. No. Yeah, I would have to calculate that azimuth. So if I looked at set my options to give me set of variance azimuth. I said 4 to 1, that should be 333. Well, let's see, 1 to 4, 333. So now 1 to 6 should be this 289.19. I copy that. Oh, wrong. And then I'll go back to edit process my raw data. I have to set this one back. Process and then save changes. And it still. Let me see something real quick here. I may have to change a record. One looking at 6. Yeah. Well, $289. Okay, so that should shift these points down. That's working there. If I say 6. Yeah, it's recomputing that. All right, so if I had that 333, like it was from, from 4, and then update raw from points. No, it's still not changing that record. Let's try to, yeah, see, it is recomputing without the azimuth record being corrected. So that's change. Let's go ahead and change that radically different to 2. Now, if I save the coordinate file, wow. Well, the effort was to show you how handy it was to do. Let me take that out and see if, yeah, that would, or maybe. Still not updating the coordinate file. All right, so that's what it should look like. None of that should matter. Maybe I do have to give it a particular point. I went from 1 to 15. Exit. Save that. Yes, save the coordinate file. There we go. All right, so you do have to process it once you make that change, but you can clear that azimuth record. And it will use these 2 points to calculate for you there. Also, a lot of times I've seen people come in here and they forget to zero their plate on the gun, even when they're using a data collector. I've got a client that does this quite a lot. And he'll come in and go, you know, I've got all these points over here. They all look good, you know, in relationship to themselves, but instead of being clustered over here, they really should be over here. They go, well, what point were you sitting on? What did you backslide? So we checked those records, everything was fine. But then we noticed up here his circle reading, he forgot to zero the plate. And like I said, he's using a data collector, but he forgot to set 0 on the plate when he was setting those points up and from his last turn. So we just simply come back and change that record, recompute that, and it positions things where he's expecting them to be. So that's the benefit, even beyond just your traverse data, that these raw files can help you work as you go. Now, again, if you do a lot of this kind of work, let me get rid of some points now. And we'll say number 5. Should take care of it. Yep. All right, so back to that original. If you do a lot of this and you want that automatically on, you can go to Carlson Configure on the settings menu under survey settings and automatically turn it on, and even automatically turn the line on, and we'll say okay and exit. All right, so now we're going to do some coordinate geometry. We'll do an occupy point. Let's say we did 1, we're going to sit on 1, and we're going to backslide 2. Let's see, we have to answer the question, P for points and 2. All right, so let's set a traverse point. So we'll just go 270, 100 feet, and call this one test will be fine. And now let's go 90, 50 feet, call that one test. That's good, but we're going to do side shots at this point. And again, we'll do 90, 50 feet. And we'll do 180, 50 feet. 270, 50 feet. All right, so once we're done with that, you notice that these lines automatically drew between traverse computations, but did not draw from my side shots. And if I go back and look at my raw file now, it's automatically captured all of that information. Now, it kept those records. You notice it appended to what we had before. So that backslide 1 to 2 up there we had before, what I would do at this point is take this down all the way to from here to here. And then save that. And then I could go on and, you know, draw things, do whatever I'm working on. And if I go back and do some more Kogo, let's do I'm going to first do an inverse to set my setup. So I'm going to go from 7 to 8. Then I'm going to turn some side shots. 90 right, 50, 180, 50. And then maybe let's traverse 135, 100. Try. All right, so see again, it drew the lines because that was a traverse command. Go back and edit that raw file. And you see what it's done. It just keeps adding on to this. And so if my initial setup, instead of being 1 to 2, was 1 to 6, see, everything gets computed in relation to that. Or I may have said instead of 8 looking at 7, I was 8 looking at 5. So it's just that part that gets done. I'll run my no adjust. I'll give it a dummy point to close on. I'll turn this to prompt, and I'm going to go, 1 to 6. Did I set 5? Where did I set 5? It was a traverse. Yep. So 1 to 6 to 5 to 6 to 8 to 12. That was all okay. All right. So we'll take that as well. We'll exit. We'll close, save the file, save the coordinate file, and then redraw my points. So now you can see it's recomputed based on those new setups, and these lines, of course, no longer apply. Okay, any questions on that kind of stuff? Like I said, it's pretty straightforward. Now, these commands, locate by distance and angle, locate intersection. Again, it's all available in Visual Kogo. It's all available here as these separate things. Like if you're going to do a distance, which is under locate at the intersection of distance. Let's say we go from here, we're 75 feet. And from here, we were 200 feet. I think those will overlap. Use geodetic distance, no. Okay, so there it gives me two possible choices where there's two circles that get computed, and these are the two places to intersect. You simply pick near which solution you want or enter the letter. So let's say I wanted that solution up there, and I'll call that one test again, and it creates a point. Okay, now what is the difference in doing that than in doing something like this? If I draw a circle from here, set the radius of 75, and do another circle from here and set the radius at 200. I think that may have missed that point. If I draw a circle from there at 200. Or did I miss that?
That looks correct to me. It's on the intersection.
Well, it should have been exactly on the intersection. I don't know why I missed it. I may have mistyped a number, or actually, well, this circle is fine. That was 200. Located, intersect, distance. First base point is 12. Distance is 75. second base point was 3. Distance was 200. And let's choose this one. All right, so now draw a circle from 12 and 75. Draw a circle from 13 to 100. Not 13. 3. 200. Try it one more time. Circle. Let's use the Carlson so I can use point numbers. Oh, I see. It's reading the 3 as this option. So I have to pick that point. All right, so see, yeah, there it does find. I must have missed something when I picked it the last time by a little bit. All right. So there's nothing in the world that keeps you from saying, drawing those circles and do a draw locate point and do a screen pick and then snap to the intersection of those circles and put your point right down there at that intersection point. And so all of those methods apply. And they work, equally as well. So you have those. There's one other place where you have some of these, and that is, see if I can. Where's the AutoCAD thing? Temporary. It should be Carlson. Let's see, snap. Maybe you don't have the AutoCAD version. Anyway, there's a toolbar that has those same little intersects that you can use. Pretty certain. There's annotation. Pogo toolbar. Need that dump. Right here. Here's your best fit circles, curves, lines, interval, points from entities, point along an arc, divide between, elevation between. Okay, create points from entities. Offset points by interval. So if you're staking curbs, for instance, and you need them to be 5 feet behind the actual curb alignment, if you have say with a curb alignment like such, and we just said it had a 25-foot radius, and then we can do the offset points by interval. So if we did this, either a centerline file or select the polyline. And we'll take that as 5 feet off. Any descriptions, we'll just say offset. Draw, draw the lines, let's draw the points using X's. And I think that should work okay. And you can do a second offset as you're doing those. If you like, let's go 10 feet behind those. Well, let's do backwards. Let's go 10 feet away and then set our second offsets as 5. You can read the elevation from a surface model if you've got one built, or a profile if you've got a road design, or we're just going to set these at 0 elevation. We'll go 10 feet, every 10 feet. Let's bring that up to say every 25 feet, 10 along the curve would be fine. I would say, okay, and there it goes. So there's my offset point. This offset is that the first is a 5 foot, and then the 10 foot, that's my secondary. So I've got 5 foot offsets for each one. I've got a radius point here for my curve. If I go around the curve, then that distance along the curve here was every 10 feet, whereas on my straightaways, it was every 25 feet. Okay, so there are some useful routines there that are handy to use to help you generate some points if you need to generate those. Okay, anything else to talk about here? Does anybody do any public land surveying at all? Good, you're up north, in the northeast. All right, so, but that's what this section corners part does. And you've got things like your triangle solutions, where you put in the values, and it'll calculate and show you. So if I've got 50 feet there, my side B is say 75 feet. 50-50, I don't have any idea. Let's see, angle C might be, let's call it a 60 degrees. And so if you hit solve it or redraw it, recalculate the things you've got here and show you the acreage. Okay, just little handy tools. Okay. So I'm now going to turn off my raw file. Notice when you choose that, you can choose a new one or just append the one you've still got open. And I'm going to turn my line drawing off. I'm going to go back to my Carlson configure survey settings and uncheck those two things. So I'm not confused when it starts doing that with coordinate geometry tools. Okay. Any questions on any of those kind of tools? They're just graphic computations that help you compute a location of a new point or points. I'm really curious. It may just be, here it is. Get the toolbar dragged out. This is what I was looking for before. Now this is a nice handy little toolbar to have. It's called transparent point or selection commands. So just like we did with coordinate geometry, and you can dock that at the top or the sides or keep it handy, or you can even type in the little shortcuts. So if I'm going to do, let's say another point, so even in the middle of any other command, like if I'm drawing a 2D polyline, and I'm going to draw from point 12 up to point 11, and I want to draw to a point that is 100 feet away from 11 and 150 feet away from 13, for instance. So if I look at these, there's my bearing distance, there's my distance. So if I say distance, now it wants me to pick a point or give a point number for the base point. I'll say 11. The distance away was going to be 100. And I went to 13. 100. Again, just like in our coordinate geometry. And again, you see, I'm not setting points. I'm in the middle of drawing polylines. And you can go to do a station offset. So if I did a station of, let's say that was 25, 50, 75, 85, let's go 95, 10 feet away. So if I'd go to station, select that, and it brings this little box up. And so I can either choose it graphically, or I'm going to say, to pick a point or enter a station. If I went, say, 25, 50, 75, 85, let's say 95. All right, I went around too far. Yes, this is 20. It must have been 20, 40, 60. And then so I would give it a left offset or a right offset if I just went 10 feet offset of that. Oh, actually, it came from that direction, I guess. Oh, yeah, that was the direction that that went. So 75, 85, say 25, 50, 75, 85, 95, and then 10 feet off created that. And it calculates it radially when I'm in that arc and gives me that position. So again, these little transparent commands are little, they're like snaps. And you can find points. And even if your point has an elevation on it, let's say, let's give that an elevation of 100 feet. And did it? Yeah. I just have to redraw that point. 13. Must not be in the point defaults again. Elevations. Wow. I don't know why that's doing that. All right. All right, so there it is, 100 feet. So if I want to draw, let's say a 3D polyline, and I go from here, and if I snap to here, that is going to be, if I look over in my properties, it starts at 0, but it goes up to 100. Okay. If, however, I want to do a similar thing, go from here to that point, but I only want the 2D point, so I can choose that to say ignore that elevation. So that's going to be like 13. And now when I look at those vertices, see I start at 0 and I go to 0. So that allows you to filter that out. Now the AutoCAD equivalent of that, of course, would be doing a regular snap point filter. You said just XY, take the point, and now it needs Z, so I would type 0 or some other number. So there now is 1 to 2 stays 0. And so you may find that of some help to have these out there. There's you can find the centroid of a closed polyline. You also now, AutoCAD has geometric center that does the same thing. They used to not have that. So these are snaps. You've generally got tangent snaps. You can get a PI snap if you wanted to find where the PI of this two line is. You can choose it from that. It would pick those two segments, intersect it, and you would find that point without having to draw the geometry to set you out there. Okay. So that is a fairly handy little thing to have out there if you do a lot of point calculations, or even when you're in the middle of drawing something that you would typically just draw on the screen. You're not generating points, but you need to locate where that is instead of having to draw that out and find out where that point is. Just come over here and grab it from these. Okay, so just keep track of those. All right. Puts us right square at our stop spot. And what we want to go through is some data sharing. I think we'll wrap all that up for tomorrow. All right, I think we're about on track with those. And let's see. One thing, and we'll do this in the morning, but I just want to talk about it. I think one of you, when we first talked over, let me see if I, from my notes, if I can find out. Who mentioned it? Chris, I think it was you. You talked about sometimes needing to do some data transfer from like civil 3D drawings and other, either other departments or other companies or whatever, to transfer this data. Was that you? I think maybe mentioned it, or
Yeah,
I think I
yeah,
meant, well, go ahead,
Oh, go ahead.
Chris, sorry.
yeah, it was kind of something like that.
okay.
Yeah.
Well, we'll go over a couple of examples in the morning with some typical things and some tools that we may not be aware that are there. Or maybe you guys are. Things like if you look at our import, we've got this land XML is a really powerful means of transferring data, and it's like DXF is for CAD, except it transfers land development type of data. And I don't mean land development desktop. I mean just land development data. It includes coordinates, surfaces, parcels, alignments, and profiles. So all of that information can transfer even right out of a Civil 3D file. You can bring across Civil 3D points, your draw styles for your profiles, your point center lines, line work, pipes, surfaces, and labels. Those are the things in a Civil 3D file that are those extended entities that you have to explode to use, or they just show up as an AECC object. So there's a really nice little handy tools to be able to do that, which you can also do individually, like just for a surface under our not profile conversion, import export surface data, where you can bring these from different places. There's a Civil 3D drawing. And what that does is it actually converts the entire drawing, but it will read those surface objects and generate your .tin file, so you're not having to build those surfaces again. The only problem I have with that is that most people I get the surface files from have really not done the best job at building the surface necessarily. So I always have to check it anyway. But if you don't have the data that built it, sometimes that's your best approach to getting the information. All right, so we'll go over that tomorrow. Just some ways of sharing things back and forth with other people. Okay, so with that, I guess if anybody have any questions, let's conclude with that. Everybody good? All right, so I will